listeners. Today we're going to dive into concrete technology.
Sounds exciting.
It is actually. I gotta say, when I first saw this like stack of notes on concrete, I thought, really? Concrete. But it's actually super interesting stuff. We're working with your notes here, getting ready for this exam you've got coming up.
Right. And it's not just about the exam, it's about understanding how this essential material shapes our world.
Yeah, for sure, for sure.
Uh,
Okay, so the notes start off, and this is kind of cool, with the history of concrete. Like, did you know the Romans were using concrete way back in the day?
Oh, yeah. The Romans, they were masters. They're using volcanic ash in their mixes, which acted as a natural cement.
Volcanic ash, really?
Yeah. It's fascinating how they figured that out. It created this incredibly durable concrete. Some of their structures are still standing today.
Wow. See, I told you. Fascinating. But it's not all ancient history. Your notes also go into all the latest innovations like self-healing concrete.
Right. And concrete that can absorb CO2 from the atmosphere.
It's like sci-fi stuff, but real. And it shows how important concrete technology is. Like, we're still finding ways to make it better, more sustainable.
Absolutely. So are you ready to jump into some of the key concepts for your exam?
Let's do it. Hit me with your best shot.
Okay, well, first up, we've got mixed design, which is crucial.
Mixed design, yeah, I see that's like flagged in the notes as super important.
It is. It's basically like a recipe. You need the right proportions of cement, water, aggregates, and often admixtures to achieve the desired properties for your concrete.
So it's like baking a cake, but instead of a delicious treat, you get a bridge or a skyscraper.
Exactly. And just like with a cake, if you get the recipe wrong, things can go bad. Too much water, for example, might make the concrete easier to work with initially,
Right, more workable.
but it can weaken the final product.
Makes sense. So finding that right balance is key. And then, of course, there's quality control, which seems like a big deal.
Huge. You got to make sure that every batch of concrete meets the required standards. Your notes mention things like slump tests.
Slump tests.
Yeah, it measures how much the concrete settles under its own weight. It's a way to assess workability.
Interesting.
And there are tests for compressive strength, air content, all sorts of things to ensure the concrete is up to par.
Makes sense. You don't want a bridge collapsing because someone messed up the concrete recipe.
Exactly. Okay, moving on. We've got durability, which is all about making sure concrete can withstand the test of time.
Because it's not like we can just replace concrete structures every few years.
Precisely. Concrete needs to resist weathering, chemical attacks, freeze-thaw cycles, you name it. Your notes highlight techniques like using air entrainment.
Air entrainment. What's that?
It's basically adding tiny air bubbles into the concrete mix. These bubbles create space for water to expand when it freezes, preventing the concrete from cracking.
Ah, so it's like giving the concrete some breathing room for those cold winters.
You got it. And then there's the sustainability aspect.
Yeah, sustainability. That's a big one these days, right?
Absolutely. The production of cement, a key ingredient in concrete, is a significant contributor to carbon emissions.
Really? I had no idea.
Oh, yeah. So the industry is looking for ways to make concrete greener. Your notes talk about using supplementary cementitious materials.
Supplementary what now?
They're materials like fly ash and slag, which are industrial byproducts. Using these can replace a portion of the cement, reducing the carbon footprint.
So it's like recycling, but for concrete.
Exactly. And the cool thing is, these materials can actually enhance concrete properties as well.
Wow, so it's a win-win.
Okay, we've covered a lot of ground here, from Roman times to sustainable concrete. But what about exam strategy? I mean, these notes are comprehensive.
Right. There's a lot to take in. But your course creators were smart. They included study tips, practice questions, and even mock exams.
Mock exams, those are key.
Definitely. They give you a feel for the exam format.
Right, like a trial run.
Exactly. Plus, it's a great way to identify your strengths and weaknesses. You might find you breeze through some topics but struggle with others, which means you can focus your studying on the areas where you need it most.
Exactly. They also mentioned flashcards. Do you ever use those?
Flashcards. Oh, yeah. Classic. Low tech, but effective. Writing down key terms or concepts, quizzing yourself, it's a great way to cement that knowledge, pun intended.
Nice one. It's all about finding what works for you. Some people are visual learners, some prefer hands-on activities. Your notes even suggest trying to build small-scale concrete models.
Oh, that's cool. Like a mini concrete lab.
Exactly. It can be a fun way to visualize those mixed design principles.
So to our listeners out there prepping for this exam, it sounds like the key is to be engaged, right?
Absolutely.
Yeah.
Don't just passively read through the material. Test yourself, create flashcards, build those mini concrete empires, whatever helps you solidify the knowledge.
It's not about rote memorization, it's about really understanding the concepts.
Precisely. And the cool thing about this is that this knowledge, it goes beyond the exam room. It's about understanding the built environment around you.
Totally. You'll start to look at sidewalks and buildings differently, appreciating the science and engineering that goes into them.
It's empowering to be able to look at a concrete structure and understand how it was made, why it's designed that way, and how it might be improved in the future.
So there you have it, listener. You're not just prepping for an exam, you're becoming a concrete connoisseur.
And who knows? Maybe this sparks a lifelong passion for the world of concrete.
You never know, but for now, focus on that exam.
All right, everyone, welcome back. So you've just finished that deep dive course on concrete technology. That's awesome. It's funny how we think about concrete, right? It's like it's everywhere, but we don't really think about it. But once you really get into it, it's like, whoa, there's a lot more to this than meets the eye. And that's what we're doing today. A deep dive. We're pulling out the coolest, most useful stuff from that course so you can walk away feeling like a concrete pro.
It's true, concrete often gets overlooked, but as you've learned, it's a fascinating material with a long history and a pretty exciting future.
Okay, so speaking of history, this just blew my mind when I learned it. Did you know the Romans were using concrete like over 2,000 years ago?
Oh, yeah.
I mean, the Pantheon, that massive dome, still standing. It makes you wonder what they knew that we've forgotten.
Right. It speaks to the durability of concrete, even with their, let's say, less sophisticated methods.
Yeah. And when you think about it, the recipe is surprisingly simple. Cement, water, aggregates like gravel, sand, that kind of thing. But here's where it gets really interesting.
It's all about the proportions. And this is a key takeaway from the course. That water-cement ratio. It's like the golden rule of concrete strength.
Yeah, that was a big one. Too much water, you're basically weakening the concrete from the inside out.
Exactly. It's like trying to build a house of cards with soggy cards. Not going to go well.
So fast forward a few centuries, and we're not just making domes and aqueducts anymore. We're talking skyscrapers, bridges, underwater structures, the stuff of engineering marvels. And a lot of that comes down to this really cool concept of reinforced concrete, or RCCs they call it. It's like taking concrete from 0 to hero.
Absolutely. Adding steel reinforcement, that rebar, was a total game changer. It's like taking something strong and making it almost indestructible.
Yeah, because concrete on its own, it's great at handling compression, like when you're pushing down on it.
Yeah.
But it's not so great with tension, like pulling it apart.
And that's where the steel comes in. It takes those tensile forces like a champ. It's teamwork at its finest.
And that's how we get those jaw-dropping structures, right? Like, imagine trying to build the Burj Khalifa, the tallest building in the world, without reinforced concrete. It would be, well, impossible.
Exactly. RCC opened up a world of architectural possibilities.
But, and this is key, none of it matters if the quality of the concrete isn't top-notch. And that's where all those quality control measures come in, like making sure the ingredients are just right and running those strength tests they talked about.
Absolutely. One of the most important is compressive strength testing. You're basically seeing how much force a concrete cylinder can withstand before it fails.
Okay, so walk me through that. How does that work?
So you have this precisely made concrete cylinder, and you put it in a machine that applies pressure, slowly increasing it until the cylinder literally crumbles.
And that tells you how strong it is.
Precisely. And different applications need different strengths. A sidewalk won't need the same strength as, say, a massive dam.
Makes sense. So what they use in like sidewalks, is that the same kind of concrete they use for everything? Because I know we also learned about all these special types of concrete.
Good point. There's a whole range of specialized concretes out there, each tailored for specific uses. For example, there's high-performance concrete. It's designed for extreme conditions like you'd find in a skyscraper or a bridge.
Right, or even those underwater tunnels they're building. That just boggles my mind.
Exactly. High-performance concrete often uses special aggregates or chemical admixtures to enhance its properties. It's like giving the concrete superpowers.
Speaking of super, we got to talk about sustainability. Because concrete, it's not exactly known for being the greenest building material out there. Well, with all the cement production and whatnot.
You're right, it's a big challenge. The production of cement is energy intensive and releases a good amount of carbon dioxide. But the industry is aware of this, and there are some really interesting advancements in sustainable concrete.
Okay, like what?
Well, for starters, there's a big push to use recycled aggregates. Think about all the concrete that gets demolished every year. Instead of going to waste, It can be crushed up and used as aggregate in new concrete.
That makes a lot of sense. Reduce, reuse, recycle. Right.
Exactly. And there's also a lot of research going into finding alternative materials to replace some of the cement in concrete, which can significantly reduce its carbon footprint.
Wow, that's incredible. It's amazing to think about how concrete has been around for centuries, and yet we're still finding ways to improve it, make it more sustainable, even push the boundaries of what it can do.
It really speaks to the ingenuity of engineers and the fact that even a material as seemingly simple as concrete is constantly evolving.
So, from those Roman aqueducts to those 3D printed concrete houses that are starting to pop up, it really makes you wonder what's next. What other crazy innovations are just around the corner?
Only time will tell.
Well, that's about all the time we have for today's deep dive.
It's been a pleasure exploring the world of concrete with you.
And to all of you listening, we hope you learned something new about the amazing world of concrete technology today. Let's talk textured concrete. You know, the stuff you see every day, but maybe haven't thought much about. It's way more than just sidewalks. We're talking luxury hotels, art galleries, places where looks meet serious durability. The cool thing about textured concrete, well, it's how versatile it is. Tough enough for your driveway, but still stylish enough for like a fancy interior. Picture this, an exposed aggregate pool deck, all those little stones. Not only is it interesting to look at, but it's also like slip resistant, super important around water, right? Or think about a polished concrete floor in a gallery, all that light bouncing around, making the space feel huge. So let's jump into some of the common types of textured concrete finishes. First up, exposed aggregate. This is where you see like the raw beauty of the stones mixed into the concrete. You see this a lot in driveways, walkways, patios, places where you need good traction. Then there's the broom finish. Pretty simple, really. You just drag a broom across fresh concrete, makes these fine lines, kind of subtle texture. Perfect for areas that get wet, like driveways and sidewalks again. The lines actually help you not slip. Now, for something a little more eye-catching, there's stamped concrete. Here they use molds to press patterns right onto the concrete. They can make it look like stone, brick, wood, even tile. It's a really good way to get that high-end look without the high-end price tag. Driveways, patios, pool decks, you see it everywhere. Okay, so making textured concrete, it's not just one and done. There's actually several steps to get that perfect finish. First, you have to prep the surface. Think of it like building a house. You need a strong foundation, right? Whether it's soil or even existing concrete. It's got to be clean and level. Any little bits of stuff, dust, bumps, it's all going to mess things up in the end. Next up is mixing the concrete. The mix is going to depend on what kind of texture you want, like a exposed aggregate. That needs a wetter mix usually. Best thing to do, check the manufacturer's guidelines just to be safe. All right, concrete's mixed. Now it's time to put it down. This is where things get exciting. If you want that stamped look, you got to use release agents. They keep the molds from sticking. Broom finish. Timing is key. You got to drag that broom at just the right moment. Not too wet, not too dry. That's how you get those nice clean lines. Concrete's down. Texture now needs to cure. This is basically letting it harden, get strong, helps prevent cracks, and makes it last longer. Last step, sealing. This protects the concrete and makes it look better, helps keep it from staining, getting water damage, all that stuff. Keeps it looking good for years. But there's more to textured concrete than just these basic things. There's some really cool techniques out there, stuff that pushes the limits. One is called microtopping. It's like giving your concrete a makeover. They put down a thin layer of this special concrete. It makes a smooth finish, and you can customize it too. You can make it look like polished concrete or even add colors and patterns. Speaking of polished concrete, that's a whole other level of sleek. They grind down the surface of the concrete until it's super glossy and reflective. Really popular for modern places, homes and businesses, gives it that sophisticated edge. And if you have some old concrete that needs a refresh, well, there's decorative concrete overlays. You put this right over the old stuff. Completely changes how it looks. You can add patterns, textures, even make it look like wood or stone. Now, let's talk about keeping that textured concrete looking good. Regular cleaning is important. Just some mild detergent and water. You want to keep dirt and grime from building up and messing up the finish. Stay away from harsh chemicals, though. Those can damage the surface. And remember sealing. Well, you got to do that more than once. Every few years, you should reseal it. It's like giving your concrete a new shield. Keeps it protected from the weather, stains, all the bad stuff. So we've covered a lot. different types of textured concrete, how to make it, even some of the new fancy techniques. But wait, there's more. Let's see how some of this stuff is used in the real world, how they make those amazing spaces, how they use concrete to make things beautiful. Those exposed aggregate pool decks we were talking about? They're not just pretty, they're really practical. Those stones, they make the surface slippers really important when you're walking around water. And the texture, it blends right in with the whole pool area.
Yeah, it's really cool how textured concrete can be both functional and good looking. It's not just about making it pretty, it's about making it work right. Like those broom finished sidewalks. They look nice, but they also give you more grip, especially when it's wet.
Totally. Form and function working together.
Hmm.
And when you think about it, textured concrete can even be part of sustainable design.
Oh, for sure. When you use local aggregates and recycled materials in the mix, you're making it more environmentally friendly. It's about being responsible from the materials to the final look.
That's a good point. It's not just the end product, it's the whole process.
Right.
And speaking of innovative processes, some of these new techniques are really pushing the boundaries, like microtopping. It's like giving your concrete a whole new look without having to, tear everything out.
Right. Microtopping is super versatile. You can use it on floors, walls, countertops. You can basically use it anywhere. And it's only a thin layer, so it doesn't add a lot of height. That's great for renovations and stuff.
So imagine you have this old concrete floor in your kitchen. Instead of ripping it up, you just put a microtopping layer over it. Now you have this smooth, modern surface. It can look just like polished concrete. Or you can get crazy with it and add colors and patterns.
Yeah, that's the cool part about microtopping. You can get so many different looks with it. You can go for that minimalist vibe or do something really bold with colors.
And of course, there's polished concrete. It's been a go-to for high-end businesses for years. But now you're seeing it in homes more and more.
Yeah.
That smooth, shiny surface, it's perfect for modern houses, gives it that touch of class.
Yeah, polished concrete is totally on trend with that minimalist design style.
Yeah.
Simple and sophisticated. It makes the space feel really calm and organized.
Totally agree. And if you want to add a little warmth to the space, you can always use rugs or something.
Yeah.
You got to find the right balance between the sleek concrete and your own style. Now let's talk about decorative concrete overlays. These are perfect for anyone who wants to update their existing concrete. You can make it look like natural stone, brick, wood, anything really. Decorative overlays open up so many possibilities.
Decorative overlays are interesting because they change how the surface feels too, not just how it looks. You can add textures that feel like real stone or wood.
Right. It's not just about seeing it, it's about feeling it too.
Yeah.
And since you're just putting it over the old concrete, it's a lot cheaper than replacing everything.
One thing people forget is that any textured concrete project, it really depends on the contractor. You can't just hire anyone who can pour concrete. You need someone who really knows how to do textured finishes, someone who can make your vision a reality.
You're absolutely right. Finding the right contractor is so important. You should definitely do some research, ask for recommendations. Textured concrete is an investment, so you want to make sure it's done right. So we've looked at a lot of different textured concrete applications. Pool decks, floors, even countertops and walls. It's clear that textured concrete isn't just for sidewalks anymore. It's a big part of modern design. Durable, beautiful, and sustainable. Now let's talk about the art and the skill that goes into making these surfaces. Creating these textured concrete surfaces is like art, isn't it? It takes real skill and understanding to turn plain concrete into something special.
Oh, yeah, absolutely. Like those artisans who do exposed aggregate, they have to carefully pick out the right stones. Think about the size, the color, how tough it is, even how slip resistant it is. And then they use these special tools to wash away the top layer of concrete. They have to do it at just the right time to show off those beautiful stones.
It's amazing how they get it so even and pretty. It must be hard to get it right.
Oh, it definitely takes a lot of precision. It's all about the water pressure, the concrete mix, and the skill of the artisan. But when they get it right, it's gorgeous. You get this raw, natural look that's tough and beautiful at the same time.
And stamped concrete, talk about artistic. They use molds to make these really detailed patterns, to look like stone or brick or wood, whatever they want.
Yeah.
They have to work fast too, right? Make sure the concrete's not too hard or too soft.
Yeah, it's all about timing with stamped concrete and making sure the molds are lined up perfectly. What's interesting is how much stamped concrete has changed over the years. The molds are way more advanced now. You can get some incredibly detailed and realistic designs. And the ways they color and stain the concrete have gotten better too. So many more options now.
It's hard to believe they can make it look so real. Like you wouldn't even know it's concrete sometimes.
Right. It really opens up a lot of possibilities for designers. And don't forget about those polished concrete floors. Making those shiny, smooth surfaces, that's an art in itself.
Yeah, it must take a lot of patience to get it so perfect.
It does, but it's so worth it. You get these elegant, long lasting floors. They're perfect for modern spaces. And when you think about how the light hits it, it's even cooler.
I've always loved how the light looks on polished concrete. It's like it makes the room brighter and more welcoming.
Exactly. It bounces light all over the place, so the room feels bigger and more open. And if you use the right lighting, you can even highlight the little differences in color and texture.
That's so cool. So it's not just about the concrete, it's about how the light interacts with it.
Exactly. And that's true for any textured concrete, really, whether it's the shadows from a broom finish or how the light hits those exposed stones. That combination of light and texture, it just adds another layer to the whole design.
So we've learned a lot about textured concrete today. It's so much more than just a boring building material. It's a way to be creative, to show off some real craftsmanship. And it reminds us that beauty can be found anywhere, even in concrete.
It's been great talking about all this with you. From simple sidewalks to amazing buildings, textured concrete can change a space completely.
So next time you see some textured concrete, take a second to think about it. Think about the artistry, how tough it is, and all the possibilities. It really shows you what we can do when we put our minds to it. We can take something ordinary. Welcome. Today we're going to be looking at textured concrete, a material that really blends practicality with aesthetics. You might be thinking, well, isn't that just for sidewalks? But it actually goes far beyond that. Textured concrete is really a design element, and it can elevate the look and feel of any space, from patios and pool decks to even the interiors of stylish homes and businesses. So imagine stepping onto a patio, right? Is it just plain concrete? Or does it have like a subtle texture, like maybe pebbles embedded within it? Well, that's textured concrete, and it's gaining immense popularity, and there's a good reason for that. Two words actually capture the essence of textured concrete's appeal: versatility and durability. So it offers that inherent strength and longevity of traditional concrete. But there's a significant bonus. It's got visual interest, it transcends mere functionality, it becomes really a design element in itself. So let's consider an outdoor pool deck. You need a surface that can handle constant exposure to the elements, right? Heavy foot traffic. But of course, you want it to look appealing as well. So this is where a textured finish, like exposed aggregate, truly shines. It's slip resistant, which is a crucial safety feature around water. And it also possesses a natural, almost earthy aesthetic that blends beautifully with outdoor surroundings. This example really illustrates how textured concrete is not just about practicality, it's really about a design philosophy that values both safety and aesthetics. Now, let's embark on a visual journey. We'll go through some of the most popular textured concrete finishes, and we'll start with exposed aggregate. So picture a surface that reveals the raw beauty of stones embedded within the concrete. That's exposed aggregate. These aggregates can be pebbles, larger stones, or even recycled glass. When the top layer of cement is washed away, these aggregates become visible. It gives the concrete a unique textured appearance, like nature is woven into the surface itself. And as we saw with the pool deck example, the texture isn't just for looks, it actually provides better grip, which makes it ideal for walkways, driveways, and other areas where safety is paramount. Next, we have the broom finish. It's a classic choice. It's very simple and functional. As the name implies, this texture is created by dragging a broom across the surface of freshly poured concrete. This leaves behind fine, linear patterns that provide just the right amount of traction, especially in areas prone to rain or snow. You'll often see broom finishes on sidewalks and driveways, where practicality and cost-effectiveness are key considerations. Now, if you're looking to make a bolder design statement, stamped concrete offers a world of possibilities. This technique allows contractors to imprint the concrete with patterns that mimic other materials, like stone, brick, wood, or even tile. Imagine the elegance of a cobblestone patio, or the rustic charm of a wood plank driveway, all achieved with the durability and affordability of concrete. Stamped concrete offers that kind of versatility. It's a popular choice for patios, pool decks, and even indoor floors. It allows you to achieve the look of high-end materials, but at a fraction of the cost. Having explored some popular finishes, let's shift our focus to understanding how textured concrete is actually created. It's a multi-step process, demands attention to detail at every stage, but we can break it down into 4 key phases. First and foremost is surface preparation. Whether you're working with freshly poured concrete or an existing slab, the surface needs to be clean, level, and free of any debris. Think of it as preparing a canvas for a masterpiece. This might involve compacting the soil for outdoor projects or removing old coatings for indoor ones. Once the surface is prepped, the next step is mixing the concrete. Now, here's where it gets interesting. The exact mix will vary depending on the desired textured finish. For exposed aggregate, for example, a slightly wetter mix is used to facilitate the washing process that reveals the aggregates. Different finishes, different mixes, and each one impacts the final look and feel of the surface. It's all about understanding the nuances of the material. With the concrete mixed, we move on to applying it and creating the desired texture. For stamped concrete, this involves using molds coated with release agents to prevent sticking. These molds are carefully pressed into the surface, creating the intended pattern. For a broom finish, timing is crucial. The concrete needs to be at just the right consistency, neither too wet nor too dry, to achieve those clean, defined lines. Finally, once the concrete is placed and textured, it's time for curing. This allows the concrete to reach its full strength, preventing cracks and ensuring a durable surface. Think of curing as allowing the concrete to set and harden properly. After curing, a sealer is applied to protect the surface from stains, water damage, and wear and tear. This sealer also enhances the color and makes the texture truly stand out. And the beauty of textured concrete is that, with proper care, it can last for years. Now, while we've covered the foundational techniques of creating textured concrete, the world of concrete design is constantly evolving. There are innovative techniques emerging that push the boundaries of what's possible with this versatile material. One such technique is microtopping. It's a process of applying a thin layer of polymer-modified concrete over an existing surface. It's like giving your concrete a makeover, creating a smooth, customizable finish that can mimic polished concrete or be used for decorative purposes. Imagine transforming a dull, worn concrete floor into a sleek, modern surface without having to pour a whole new slab. That's the power of microtopping. Another technique gaining popularity is polished concrete. It's a process that grinds down the surface of the concrete to reveal a smooth, reflective finish. It's a popular choice for high-end spaces, where a minimalist, contemporary look is desired. Imagine a light-filled living room with a polished concrete floor that reflects the sunlight, creating a sense of spaciousness and elegance. That's the visual impact polished concrete can achieve. And finally, we have decorative concrete overlays, a fantastic option for revitalizing old, tired concrete surfaces. These overlays are thin layers of concrete applied over existing concrete, allowing for a wide range of patterns, textures, and even the mimicry of natural materials, like wood or stone. Imagine taking a cracked, faded concrete patio and transforming it into a beautiful space that resembles a cobblestone courtyard or a flagstone walkway. That's the kind of transformation decorative concrete overlays can achieve. So we've journeyed through the world of textured concrete, exploring its versatility, durability, and the craftsmanship that goes into creating it. But one crucial aspect remains: maintaining this beautiful surface. While textured concrete is renowned for its durability, it still requires some care to maintain its best appearance. The good news is that maintaining it is relatively straightforward. The key is regular cleaning. Like any surface, textured concrete can accumulate dirt, grime, and stains over time. However, harsh chemicals are a definite no-no. They can damage the sealer and dull the finish. Instead, opt for gentle cleaning using mild detergent and water. A simple scrub with a soft bristled brush will do the trick for most everyday dirt and spills. For tougher stains, a specialized concrete cleaner might be necessary. Always test any cleaner in an inconspicuous area first to make sure it doesn't discolor the concrete. Now remember, that sealer we discussed earlier is not a one-time application. Over time, especially in high traffic areas or outdoor spaces exposed to the elements, the sealer will wear down. Reapplying the sealer every few years is vital to maintain the concrete's protection and keep it looking its best. Think of it like giving your textured concrete a rejuvenating spa treatment. It helps preserve its beauty and extend its lifespan. After all, you wouldn't buy a new car and then neglect its maintenance, would you? Textured concrete deserves the same level of care to truly shine. So we've completed an in-depth exploration of textured concrete, from the various finishes to the steps involved in its creation, and the importance of proper maintenance. Before we conclude, I'd like to leave you with a thought. Now that you have a deeper understanding of textured concrete and its possibilities, how might you envision it being used in your own home? or in public spaces you encounter. Perhaps a sleek, polished concrete floor in your living room, a stamped concrete patio for summer gatherings, or an exposed aggregate driveway that adds a touch of natural beauty to your curb appeal. Possibilities are truly endless. And with the knowledge you've gained today, you can appreciate the artistry and craftsmanship that go into creating these stunning and durable surfaces. If this exploration has sparked your curiosity, there's a wealth of resources available online. Forums and websites dedicated to concrete design can provide a treasure trove of inspiration and practical tips. And if you're considering a textured concrete project for your own home, connecting with local contractors specializing in this type of work is a great next step. They can offer expert advice tailored to your specific needs and vision. So that wraps up our deep dive into the creation and care of textured concrete. But before we part ways, I want to shift gears and delve into something truly fascinating: the evolution of concrete as a design element. You might be surprised to learn that the use of concrete as a building material stretches back thousands of years. The Romans were pioneers in concrete construction, using it to build remarkable structures like the Pantheon and the Colosseum. Their concrete was incredibly durable, withstanding the test of time for centuries. However, for much of history, concrete was primarily seen as a structural material, hidden beneath layers of plaster or other finishes. It wasn't until the mid-20th century that architects and designers began to embrace the aesthetic potential of concrete, leaving it exposed and celebrating its raw industrial beauty. This shift in perspective was fueled by the rise of modernist architecture, with its emphasis on clean lines, functional forms, and a rejection of ornamentation. Concrete, with its inherent strength and versatility, became the ideal material for expressing this new architectural language. Think of iconic structures like Le Corbusier's Villa Savoy or Frank Lloyd Wright's Fallingwater. Both masterpieces showcase the beauty and expressive power of exposed concrete. As concrete technology advanced, so too did the possibilities for its use in design. New techniques for coloring, texturing, and finishing concrete emerged, further expanding its creative potential. And this brings us to the textured concrete we've been discussing today. It's a testament to the ongoing evolution of this humble material, constantly being reinvented and reimagined by architects, designers, and craftspeople. Textured concrete is more than just a surface treatment. It's a way of imbuing concrete with character, depth, and visual intrigue. It enables us to create spaces that are both functional and beautiful, blending the practicality of concrete with the artistry of design. So as you navigate your city, your neighborhood, or even your own home, take a moment to appreciate the textured concrete surfaces you encounter. They are a testament to the ingenuity of human creativity, transforming a simple material into a canvas for endless design possibilities. And who knows what the future holds for textured concrete? With advancements in material science and digital fabrication, we can only imagine the innovative techniques and stunning designs that will emerge. Perhaps we'll see self-healing concrete that repairs itself over time, 3D printed concrete structures with intricate textures, or even concrete that absorbs pollutants from the air, contributing to a healthier environment. The journey of concrete, from ancient Roman structures to the cutting-edge designs of today, is a testament to its enduring appeal and boundless potential. It's a material that continues to inspire and challenge us, pushing the boundaries of what's possible in architecture and design. And that concludes our textured concrete deep dive. I hope you've enjoyed this exploration of this versatile and fascinating material. Remember, concrete is more than just a building block. It's a canvas for creativity, a testament to human ingenuity, and a material that will continue to shape our built environment for generations to come. Let's delve a little deeper into the world of textured concrete and consider how its applications go beyond just its functionality. I mean, we often associate concrete with strength and durability, right?
Yeah.
But its textured forms really allow for a nuanced interplay of light and shadow, creating a visual depth that can transform the space. So imagine a modern loft apartment with those polished concrete floors. That smooth reflective surface, it bounces light around the room, right? Creating a sense of spaciousness and airiness. Now contrast that with a cozy outdoor patio featuring stamped concrete that mimics the look of cobblestone. That textured surface, with its varying depths and crevices, it creates a sense of warmth and intimacy. These examples really illustrate how textured concrete can be used to evoke different moods and aesthetics. It's not just about the material itself, but about how it interacts with light, with shadow, and with the surrounding environment. Now let's shift our focus to the historical context of concrete as a design element. As we mentioned earlier, the use of concrete dates back thousands of years, with the Romans being masters of its application in construction. However, for centuries, concrete was largely relegated to a structural role, hidden beneath other finishes. It was in the mid-20th century that architects and designers began to see concrete in a new light, recognizing its inherent beauty and expressive potential. And this shift actually coincided with the rise of modernist architecture, which was a movement that really embraced simplicity, functionality, and a rejection of unnecessary ornamentation. Concrete, with its raw industrial aesthetic and malleable nature, became the perfect material for expressing these modernist ideals. Iconic structures like Le Corbusier's Villa Savoye and Frank Lloyd Wright's Falling Water exemplify this shift. They showcase the beauty and versatility of exposed concrete. These architects, they recognized that concrete didn't need to be hidden. It could be celebrated for its inherent qualities, its strength, its texture, its ability to be molded into fluid forms. This marked a turning point in the history of concrete, elevating it from a purely functional material to a design element in its own right. And as concrete technology progressed, new techniques for coloring, texturing, and finishing concrete emerged, further expanding its creative possibilities. This brings us back to the textured concrete we've been exploring today, a testament to the ongoing evolution of this versatile material. The various techniques we've discussed, from exposed aggregate to stamped concrete and beyond, represent a culmination of centuries of innovation and experimentation. So textured concrete allows us to bridge the gap between functionality and aesthetics. We can create surfaces that are both durable and visually captivating. Now let's step back and consider the broader implications of textured concrete's popularity. Its widespread use really reflects a growing appreciation for materials that are both honest and aesthetically pleasing. In a world that's often dominated by synthetic materials and mass production, textured concrete offers a sense of authenticity, a connection to the raw materials and the craftsmanship involved in its creation. It's a reminder that beauty can be found in the simplest of things, in the textures and imperfections that make each surface unique. Furthermore, the versatility of textured concrete aligns with the increasing demand for customization and personalization in design. Whether it's a homeowner seeking a unique patio design or an architect envisioning a striking building facade, textured concrete offers a canvas for expressing individual style and creativity. As we move forward, it's exciting to consider the future possibilities of textured concrete. Advancements in material science and digital fabrication are constantly pushing the boundaries of what's achievable. Imagine, like self-healing concrete that can repair its own cracks over time, reducing maintenance and extending its lifespan. Or perhaps 3D printed concrete structures with intricate textures and patterns, offering unparalleled design freedom. We might even see concrete that interacts with its environment, absorbing pollutants from the air or changing color in response to temperature fluctuations. The possibilities are limited only by our imagination and our ability to harness the potential of this incredible material. But beyond these technological advancements, the enduring appeal of textured concrete lies in its ability to connect us to something deeper, to the raw beauty of nature, to the artistry of human craftsmanship, and to the timeless elegance of simple forms. As you go about your day, take a moment to notice the textured concrete surfaces around you. Observe how light plays across their surfaces, how their textures evoke different moods, and how they seamlessly integrate with their surroundings. You'll find that textured concrete is more than just a building material. It's a testament to human ingenuity, a canvas for creativity, and a reminder that beauty can be found in the most unexpected places. Now let's shift gears and explore another fascinating aspect of textured concrete: its environmental considerations. So while concrete is often perceived as a purely industrial material, there are growing efforts to make its production and use more sustainable. One key area of focus is reducing the carbon footprint of concrete production. Traditional cement manufacturing is a significant contributor to greenhouse gas emissions. However, researchers and manufacturers are exploring alternative materials and processes that can lessen the environmental impact. For instance, the use of supplementary cementitious materials like fly ash and slag can reduce the amount of cement needed in concrete mixes. And these materials are industrial byproducts that would otherwise end up in landfills. Another approach is carbon capture and storage, a technology that captures carbon dioxide emissions from cement plants and stores them underground, preventing their release into the atmosphere. In addition to reducing the carbon footprint, sustainable concrete practices also focus on using recycled materials. Recycled aggregates, such as crushed concrete and demolition debris, can replace virgin aggregates in concrete mixes, conserving natural resources and reducing waste. The use of recycled water in concrete production is another sustainable practice. This reduces the demand for fresh water, a particularly important consideration in areas facing water scarcity. These sustainable concrete practices are gaining traction as awareness of environmental issues grows. Architects, designers, and builders are increasingly seeking out eco-friendly concrete options for their projects. This shift towards sustainable concrete is encouraging because it demonstrates a commitment to reducing the environmental impact of construction while still harnessing the versatility and durability of this essential material. Furthermore, textured concrete itself can contribute to sustainability in several ways. Its durability means that surfaces last longer, reducing the need for frequent replacement and minimizing waste. The use of textured concrete in landscaping can also promote water conservation. Permeable concrete surfaces allow rainwater to seep into the ground, replenishing groundwater and reducing runoff. And, as we touched upon earlier, textured concrete's ability to mimic natural materials like stone and wood can reduce the demand for these resources, helping to preserve natural ecosystems. So, as we appreciate the aesthetic and functional qualities of textured concrete, let's also recognize its potential to be a part of a more sustainable future. By choosing eco-friendly concrete options and incorporating textured concrete into our designs in mindful ways, we can contribute to a built environment that is both beautiful and environmentally responsible. Now let's transition to another intriguing aspect of textured concrete: its ability to enhance accessibility and safety in our built environment. While we often focus on the visual appeal of textured surfaces, their tactile qualities also play a crucial role. Consider, for example, the use of textured concrete in public spaces to create detectable warning surfaces for people with visual impairments. These surfaces, often found at the edge of train platforms or pedestrian crossings, provide a tactile cue that alerts individuals to potential hazards. The use of textured concrete in ramps and walkways can also improve accessibility by providing better grip, particularly in wet or icy conditions. This benefits everyone, from wheelchair users to older adults and individuals with mobility challenges. Furthermore, textured concrete can enhance safety in areas prone to slips and falls. As we discussed earlier, finishes like exposed aggregate and broom finish provide increased traction, reducing the risk of accidents. This is particularly important in outdoor spaces, around pools, and on walkways exposed to the elements. So by incorporating textured concrete into our designs with accessibility and safety in mind, we can create environments that are inclusive and welcoming for all. These seemingly small details can have a significant impact on people's lives, making spaces easier and safer to navigate. Now let's shift our focus to the realm of artistic expression and explore how textured concrete has become a canvas for creativity in its own right. Beyond its functional and practical applications, textured concrete has inspired artists and designers to push the boundaries of what's possible with this versatile material. Sculptors have embraced textured concrete for its ability to capture intricate details and create expressive forms. The interplay of light and shadow on textured surfaces adds a dynamic dimension to sculptures, enhancing their visual impact. Muralists have also discovered the potential of textured concrete as a backdrop for their artwork. The texture of the concrete can add depth and dimension to murals, creating a unique visual interplay between the artwork and the surface. Even furniture designers have incorporated textured concrete into their creations. Concrete tables, chairs, and benches with textured surfaces offer a unique blend of industrial chic and tactile appeal. These examples demonstrate how textured concrete has transcended its traditional role as a building material and become a medium for artistic expression in its own right. Its versatility, durability, and ability to evoke different moods and textures have inspired artists and designers to explore new possibilities and create works that are both visually stunning and conceptually engaging. As we conclude our exploration of textured concrete, let's take a moment to reflect on its significance in the broader context of design and architecture. Textured concrete represents a shift away from the uniformity and mass production that often characterize modern construction. It's a reminder that materials can be both functional and aesthetically pleasing, that imperfections can add character and beauty, and that human craftsmanship plays a vital role in creating spaces that are both durable and inspiring. Textured concrete encourages us to appreciate the tactile qualities of our surroundings, to consider the interplay of light and shadow, and to embrace the beauty of simple forms. It's a material that connects us to the raw elements, to the artistry of human creation, and to the timeless elegance of nature's textures. As we move forward, let's continue to explore the possibilities of textured concrete, both in its traditional applications and as a canvas for innovation and creativity. Let's embrace its versatility, its durability, and its ability to transform spaces into works of art that are both functional and visually captivating. And most importantly, Let's appreciate the craftsmanship and artistry that go into creating these textured surfaces, a testament to the human spirit's enduring quest to blend beauty and practicality in the built environment. So as we wrap up our exploration of textured concrete, I want to leave you with a final thought. We've covered a lot of ground here. We talked about its history, its versatility, how sustainable it can be. We even touched on its artistic potential and how it can be used to make spaces more accessible and safe. But maybe the most remarkable thing about textured concrete is its ability to evoke a sense of place. A connection to our surroundings, a feeling of being grounded in the material world. Think about those cobblestone streets, in some old European city, or maybe the smooth, polished concrete floors you see in a modern art gallery, or even that rough texture of an exposed aggregate pathway in a garden. Each of those surfaces has a story to tell. They evoke a certain mood, and they contribute to the unique character of the space, right? Textured concrete, in all its different forms, it reminds us that we're part of a larger material world, a world shaped by natural forces and, of course, human ingenuity. It encourages us, I think, to slow down a bit, to pay attention to those textures and details all around us, and to appreciate the craftsmanship, the artistry that goes into creating the spaces we inhabit. So if you go about your day, just take a moment, to notice those textured concrete surfaces. Feel the roughness of exposed aggregate under your feet. Or maybe trace the patterns of a stamped concrete patio with your fingertips. Or even just look at that reflective gleam of a polished concrete floor. Let those textures inspire you. Let them remind you of the beauty in the everyday and how they connect us to this rich history and the enduring potential of this really remarkable material. Remember, concrete is more than just a building block, right? It's a canvas for creativity, it's a testament to human ingenuity, and it's a material that will undoubtedly continue to shape our world for generations to come. I hope you've enjoyed this deep dive and that it's given you a new appreciation for this versatile, fascinating material.
All right, get ready, because we're taking a deep dive today, and this one's a little different, even for us. We're going to be talking concrete technology, the usual. But here's the twist. We're getting our information from a YouTube video. And not just any YouTube video, a Malayalam language one aimed at Indian civil engineering students.
Yeah, I bet some people are thinking, Malayalam for concrete, how does that even work? But that's what makes it so interesting, don't you think? It's like we get to peek into how another culture looks at something so fundamental to engineering and building. Who knows what we might find?
Totally. The video we're looking at is called Get This, Concrete Technology RCC, Important Questions for Overseer Exam, Malayalam Manu Barrage. It's on YouTube from a channel called Amaze Academy for Civil Engineering. Sounds intense.
And the title alone tells us something really important. This isn't just some theoretical deep dive into the chemistry or something. This video is prepping people for an actual job. An overseer exam, meaning we're getting insights into the practical stuff construction supervisors in India need to know. It's like we're sneaking a peek at their training manual, right?
I like the way you think. And there's no better place to start than the heart of concrete itself, am I right? The cement-water ratio. This video doesn't mess around. They really stress how vital that ratio is for making sure concrete is strong.
Rightfully so. Because if you mess that up, it's not just a cracked sidewalk you're dealing with.
Yeah.
We could be talking bridges collapsing before they're even done.
Yeah.
The video really makes you understand that inverse relationship. Less water, denser mix, stronger concrete.
Right.
It's a big deal.
Absolutely. It's like, I don't know, baking a cake or something. You put in way too much liquid and the whole thing's a soggy mess, right? Too much water in your concrete and you're going to have a really bad time. It just won't be strong enough to do its job. And speaking of different jobs and strength, the video spends some time on the different grades of concrete, specifically calling out M20 and M25.
And this is where it gets kind of cool for those of us who aren't concrete experts. Because think about it, you're not going to use the same concrete mix for a small garden wall that you'd use for, say, a massive skyscraper, right? Those grades, that M20, M25, it's basically a shorthand for engineers. It tells them exactly how strong the concrete is so they can pick the right one for the job.
Yeah, like choosing the right tool out of a toolbox. But in this case, the tool is a very specific mixture of cement, water, aggregate. And while we're on the subject of making sure things are done right, the video keeps mentioning these Indian standards IS codes, they call them, specifically IS 4326 and IS 1603.
See, I find those codes so interesting. because they show us just how crucial it is to have everything standardized, not just in India, but really everywhere. It's like, think of it as the rule book for making sure all construction is up to par, so to speak. Safe, high quality, everyone's on the same page, from India to, well, you name it. Makes you wonder, though, are those standards very different from what we're used to in, say, Europe or the US?
That's a great question, and honestly, it's making me think. Like, you've got different climates around the world, right? The stuff you can even get to make concrete varies too. Maybe even cultural factors play into it. And speaking of the practical side of actually using concrete on a job site, the video seems pretty focused on workability, would you
Oh,
say?
for sure, yeah. Workability meaning how easy it is to actually work with that concrete before it hardens.
Hmm.
Pouring it, spreading it, getting it into all those shapes and forms they need.
Yeah.
Because it's one thing for a concrete mix to be strong on paper, but if it's so stiff and dry you can barely pour it out of the truck, well,
Hmm.
that's a problem.
Exactly. So you have to think about everything, the consistency of the mix, even what the weather's doing that day. It's like you could have the most amazing, strong concrete ever invented, but if you can't even work with the stuff because it's like trying to shape solid rock,
Hmm,
what's the point?
you got it. And that's why understanding things like admixtures and how temperature affects setting time, all that stuff matters in the real world of construction. You need that balance, strong and durable, but also something the team can actually handle. And of course, as long as we're talking strength and durability, we have to get into reinforced concrete, or RCC as they often call it.
Right. And that's where it gets really cool, at least for me, because now we're talking about literally putting two very different materials together, concrete and steel reinforcement,
Huh.
and somehow magically they make something even better.
It's a classic example, right? Taking advantage of each material's strengths and making up for their weaknesses. So, concrete, it's amazing at handling compression, like the weight pushing down on a column. But when you have something pulling on it, tension, like in a beam that's under stress,
Mm.
concrete doesn't do so well. That's where those steel reinforcements come in.
A perfect partnership, like you said. Concrete's got the squeezing, steel handles the stretching, and together they create a structure that can handle just about anything you throw at it. Which actually brings us back to that bigger picture we were talking about earlier, don't you think?
It really does. It's amazing how much these core ideas, these fundamental concepts, they just cut through all those language barriers.
Yeah.
We might be getting this from a Malayalam video, but these principles, they hold true whether you're building in Dubai or in Brazil. It's a global language in a way.
It's like you're getting a secret message from the way they talk about it, even if we don't speak the language. And it makes you realize even the words they use for this stuff probably tell a story, right?
Well, absolutely. It's like listening in on another world's conversation about concrete. And while we can't translate every single word, you start to feel the nuances, the places where they put the emphasis. For me, it was that word they kept using for inversely proportional. When they were talking about that cement water ratio, like the way the speaker emphasized it, it just hit differently, made it clear how important it was.
Exactly. Sometimes a different angle, a new way of saying things, it just makes it click, you know? So we've covered a lot here. The cement water ratio, the whole grading system for concrete, what workability really means when you're on a job site, how smart it is to use steel reinforcement, even dipped our toes into Malayalam and construction lingo. What do you think our listeners should really take away from all this? What's that one big idea they should remember?
That's a tough one. There's so much here. But if I had to pick just one thing, it'd be how it's all connected. This video, even though we barely understand the language and it's focused on this very specific exam in India,
Mhm.
it shows us the universal truths about concrete, about how we build things. The same rules apply, whether you're making a skyscraper in Dubai or a bridge in the Amazon. You know what I mean? It's kind of powerful when you think about it.
You're totally right. That's a really cool way to look at it. It makes this one video, this little peek into Malayalam concrete world, it becomes about something so much bigger. It's global. Makes you think, what other engineering secrets are out there, right? Hidden in plain sight, just waiting for someone to translate them and show us what's possible.
Exactly. And that's really what we're trying to do with this whole deep dive, right? It's not just about memorizing facts about concrete. It's about opening up to how much knowledge is out there. Sometimes it comes from the places you'd least expect, and even if we don't understand every detail, there's still something to be learned from making those connections.
You know what they say. The more you learn, the more you realize you don't know. this deep dive. It's the perfect example of that. We've just scratched the surface of this whole Malayalam concrete world, and already it's got me asking all sorts of new questions. And speaking of questions, we did promise our listeners a thought provoking one, something to chew on long after they're done listening. So, what's that final thought we're leaving them with today?
Yeah, it's really true. A little curiosity can take you a long way. So think about those different standards around the world we were talking about. Here's something to think about. What could we learn from those differences? Maybe there's some amazing innovation in concrete tech that's being used in India or somewhere, and we're totally missing out because we're so focused on our way of doing things. Like maybe there are even old techniques or even just different materials they use over there that honestly could really help us out here too.
Wow, you just blew my mind a little. That's a really great point. Makes you wonder what they figured out that we haven't. It's like learning goes both ways, right? There's no one right answer when it comes to engineering.
Exactly. And that's why this whole thing, even though it started with just one YouTube video in Malayalam, it's got so much bigger than that. It reminds us that there's a whole world of knowledge out there, and sometimes the most unexpected things can teach us something new.
I think that's a perfect note to end on. Who knew we'd learn so much from a deep dive into Malayalam concrete, right? So, to everyone listening, thanks for joining us. Keep your minds open and hey, maybe check out some international construction sometime. You never know what you'll find. Until next
Welcome. Today we're diving deep into all things concrete, using as our guide the Sitka Concrete Handbook. We'll be breaking it down and dispelling some common myths and exploring the fascinating world of, well, its production and applications. You might be surprised to learn that concrete is far more than just a simple mixture. It's a material that's shaped our civilization and is still evolving today to meet modern challenges like, especially, sustainability. So before we get into it, I'll quickly run through what we'll cover. We'll start with why concrete's more than just a mixture, then explore the environmental impact of its production and how the industry is, striving for sustainability. And finally, we'll delve into the five key components that make up concrete: cement, water, aggregates, admixtures, and their crucial roles in shaping that final product. So let's start by busting that myth that concrete is just a simple mix. The Sitka Concrete Handbook reveals that concrete is actually a complex matrix of 5 key components. It's this intricate interplay between cement, water, aggregates, things like sand and gravel, and admixtures that gives concrete its amazing versatility, from towering skyscrapers and massive bridges to even sidewalks and intricate architectural facades. This material really does shape our built environment, but with such widespread use, comes a responsibility to address its environmental impact. And the handbook sheds light on this by going into the carbon footprint that's associated with cement manufacturing, a significant concern given the sheer volume of concrete used globally. This leads us to a crucial question: how can something as seemingly simple as concrete be sustainable? Well, the Sitka Concrete Handbook actually offers several answers. It highlights the growing need for sustainable practices in the industry and gives insights into how we can actually achieve this. One of the key strategies that's discussed is the use of concrete admixtures. These admixtures can play a critical role in reducing the cement and water content needed in concrete mixes, which leads to lower carbon dioxide emissions. For example, the handbook highlights the use of superplasticizers in the construction of a massive ethylene concrete buffer tank in Belgium. By reducing the water and cement content, these admixtures really significantly lower the environmental footprint of the project. Another approach discussed is the concept of life cycle assessment. This method evaluates the environmental impact of concrete throughout its entire lifespan, from the initial raw material extraction all the way to its disposal. By understanding the full picture, LCA guides us toward more sustainable practices, encouraging us to consider the long-term consequences of our material choices. Besides superplasticizers, the handbook also talks about using other admixtures to improve sustainability. One example is admixtures that actually allow the use of recycled aggregates. And this is really relevant in a world where conserving resources and minimizing waste are top priorities. A compelling example from the handbook is the construction of a sports stadium in Zurich using recycled aggregates from excavated material. This project really significantly reduced raw material extraction and transportation pollution and demonstrated the potential of circular economy principles in concrete construction. Now let's shift our focus to the five pillars of concrete, the components themselves. The handbook breaks down each component in detail, starting with cement. Cement, often called the glue that holds concrete together, comes in different types, each with its unique properties. The most common type, Portland cement, involves a really fascinating production process, heating a mixture of limestone, clay, and other materials to incredibly high temperatures. Now, while this process is energy intensive and contributes to cement's high carbon footprint, the handbook does provide valuable insights into how the industry is working to reduce this impact. Moving on to water, we learned that it's not just a mixing agent, but also a factor that significantly influences concrete properties. The handbook really emphasizes that water quality is key, discussing the suitability of various water sources and highlighting potential problems with impurities that can affect the concrete's performance. You might be surprised to know that seawater can be used for non-reinforced concrete. However, due to its high chloride content, it's not suitable for reinforced or pre-stressed concrete. This just goes to show how even seemingly simple components like water, require careful consideration in concrete production. Next up are aggregates, which make up the bulk of the concrete's volume. The handbook delves into the different types of aggregates, both fine and coarse, natural and recycled, explaining how they impact the concrete's strength, workability, and even its aesthetics. Aggregates can be thought of as kind of the skeleton of concrete, providing structural integrity and influencing the final texture and appearance. Finally, we get to admixtures, which are often described as the magic ingredients that fine-tune concrete properties.
Yeah.
Admixtures are really versatile. They can reduce water content, control setting time, entrain air, and even enhance durability. The handbook provides a comprehensive overview of these admixtures and their wide range of functions, emphasizing how they contribute to both performance and sustainability. The handbook also stresses the importance of mixed design, where the proportions of all these components from cement to admixtures are carefully balanced. This delicate balancing act is critical for achieving those specific performance requirements for different applications. Whether it's a high-rise building or a simple sidewalk, mixed design ensures that final product meets the demands of the project. So having examined the individual components, let's transition from those static ingredients to the dynamic properties of fresh concrete. The handbook really emphasizes that fresh concrete is a living material, constantly evolving, before it hardens. This dynamic nature makes it both challenging and fascinating to work with. The handbook dives into key properties like workability, setting time, air content, and the phenomena of bleeding and segregation, explaining how these factors can influence that final concrete quality. Workability, which refers to how easily fresh concrete can be placed, compacted, and finished, comes in different consistence classes, measured by tests like the Slump test. This test measures the concrete's ability to flow, ensuring that it can be properly placed and finished. The setting time is another critical property. It determines how quickly the concrete begins to harden. The handbook explores those factors that influence setting time and how admixtures like retarders and accelerators can be used to actually control this process, allowing for flexibility in construction schedules. Air content is particularly important in regions with freeze-thaw cycles. Through air entrainment, achieved by using specific admixtures, tiny air bubbles are created within the concrete. These bubbles actually act as miniature chambers, providing space for the water to expand when it freezes, preventing damage to the concrete structure. The handbook also addresses two challenges that can occur in fresh concrete: bleeding and segregation. Bleeding is the tendency of water to rise to the surface, while segregation describes the separation of aggregates from the cement paste. Both phenomena can compromise the concrete quality, but the handbook provides insights into how they can be minimized through proper mixed design and handling techniques. As you can see, even in its fresh state, before it even begins to harden, concrete presents a multitude of factors to consider, each playing a crucial role in that final product's quality and performance. Now, let's turn our attention to the various methods of concrete application, each tailored to specific project requirements and construction scenarios. The handbook offers a fascinating overview of these methods, starting with a traditional crane and bucket approach. Crane and bucket, while simple and versatile for placing a wide range of concrete types, has limitations in terms of the volume placed in a given time. The handbook then discusses pumped concrete. This is ideal for large-scale projects and high placement rates. It emphasizes the importance of a suitable mixed design for pumpability as the concrete needs to flow smoothly through the pump lines without segregating or blocking those pipes. Pumped concrete has really revolutionized modern construction, allowing efficient placement even in the most challenging locations. Moving on from traditional methods, the handbook introduces self-compacting concrete, or SEC, an innovative solution for complex geometries and congested reinforcement. SEC flows effortlessly into place, even in tight spaces with minimal need for vibration. This reduces labor and noise, making it ideal for urban environments and intricate designs. The handbook highlights SEC's unique flow properties and advantages for achieving those high quality finishes with reduced effort. SEC truly showcases the continuous innovation happening in concrete technology. The handbook also explores sprayed concrete. This is often used for tunnel linings and slope stabilization. It explains how sprayed concrete can be applied directly onto surfaces without formwork, a highly flexible and efficient method showcasing concrete's adaptability to those diverse construction environments. Sprayed concrete can even be used for underwater applications. Finally, the handbook discusses precast concrete. This is where elements are cast in a controlled factory setting before being transported to the construction site. Precast concrete offers advantages like faster construction times and improved quality control as elements are produced in dedicated environments with optimal curing conditions. The handbook explains the different types of precast elements and emphasizes efficient curing methods for achieving the desired strength and durability. Now that we've explored the dynamic world of fresh concrete and its diverse application methods, let's transition to the properties of hardened concrete. We'll be exploring how it gains strength and durability over time through the fascinating process of hydration. Hydration, the chemical reaction between cement and water, is the key to concrete's transformation from a fluid paste to a solid, durable material. The handbook breaks down the key properties of hardened concrete, starting with compressive strength. It's the concrete's ability to resist crushing under load. Compressive strength is really fundamental to the concrete structural integrity. The handbook discusses those factors that influence compressive strength, such as the water to cement ratio, the type of cement used, and the curing conditions. It explains how compressive strength is determined using standardized tests where cylindrical or cubic specimens are subjected to increasing pressure until failure. Next, the handbook moves on to flexural strength. This is concrete's ability to resist bending or cracking under load. Flexural strength is especially important for structural elements like beams and slabs that are subjected to bending forces. The handbook explains how this property is tested, usually by applying a load at the center of a beam specimen until it breaks. The handbook also introduces Young's modulus of elasticity, or the E modulus, which represents concrete stiffness and resistance to deformation under load. This property is crucial for understanding how concrete will behave under stress and for designing structures to withstand those anticipated loads. The E modulus essentially measures how much concrete will stretch or compress under a given force. It's a key factor in structural engineering calculations. Finally, the handbook dives into durability. This encompasses a range of properties that determine how well concrete will withstand environmental conditions and resist deterioration over time. Durability ensures that concrete stands the test of time, from harsh weather to chemical exposure and everyday wear and tear. The handbook discusses various aspects of durability, including water tightness, frost resistance, sulfate resistance, and abrasion resistance, emphasizing how proper mix design, construction practices, and curing methods contribute to a durable and long-lasting structure. Now let's take a closer look at watertight concrete construction. The handbook introduces the white box concept, a comprehensive approach to building watertight structures that goes beyond simply using a waterproof concrete mix design. The white box concept emphasizes carefully designed joints to accommodate concrete shrinkage and movement preventing cracks that could allow water to get in. It also highlights the need for proper concrete placement techniques to ensure a homogeneous and compact structure, minimizing the risk of voids and leaks. In essence, the white box concept is a holistic approach, considering every aspect of construction to ensure a truly watertight structure. Next, the handbook provides practical guidance on various aspects of concrete construction, sharing insights gleaned from years of experience and expertise. It starts with formwork and release agents, discussing their selection and use to ensure clean and defect-free concrete surfaces. Formwork provides that temporary mold for shaping the concrete, while release agents prevent the concrete from sticking to the formwork, allowing for easy removal. The handbook emphasizes choosing appropriate materials for both formwork and release agents, considering factors like the type of concrete, the desired finish, and the environmental conditions. The handbook also provides practical tips for concrete installation, emphasizing proper pouring techniques, vibration, and finishing to achieve the desired concrete quality and appearance. Proper vibration ensures that the concrete's adequately compacted, eliminating air pockets and achieving a dense and durable structure. Finishing techniques like troweling or brushing, create that desired surface texture and appearance. Finally, the handbook provides detailed recommendations on curing methods and durations. Curing is a crucial step involving maintaining adequate moisture and temperature for fresh concrete to allow for that optimal hydration and strength development. The handbook explains different curing methods, such as covering the concrete with plastic sheeting, applying curing compounds, or misting with water. It emphasizes the importance of protecting fresh concrete from premature drying and temperature extremes to prevent cracking, reduce strength, and diminish durability. Proper curing is essential for maximizing concrete strength and durability, ensuring it withstands the test of time and performs as intended. It's amazing how much attention to detail is required at every stage of concrete production, from selecting the right materials to the final curing process. And the Sitka Concrete Handbook does a fantastic job highlighting the key considerations and best practices for achieving that high quality, durable concrete. Now let's delve into some specific types of concrete, each tailored to meet particular performance requirements. The handbook provides insights into various concrete types, starting with waterproof concrete, essential for structures like basements and underground tanks. Waterproof concrete prevents water from penetrating the structure, protecting it from moisture damage and maintaining its integrity. The handbook explains that achieving waterproof concrete involves a combination of factors: a low water to binder ratio, using pore blocking admixtures, and meticulous attention to detail during construction. It also emphasizes the importance of a well graded aggregate mix and thorough compaction to minimize voids and ensure a dense, impermeable concrete matrix. The handbook then revisits pumped concrete, which is often used for those large scale projects and high placement rates. It highlights the importance of a cohesive mix design for pumpability, ensuring that the concrete can flow smoothly through pump lines without segregating or blocking the pipes. The mix design must be tailored to the specific demands of the pumping process, balancing flowability with stability to prevent segregation and ensure efficient placement. The handbook also provides guidance on selecting appropriate pumping equipment and techniques, emphasizing the need for skilled operators who understand the nuances of pumped concrete. Now, let's turn our attention to self-compacting concrete, or SCC, which has revolutionized concrete construction in so many ways. The handbook explains how SCC's unique flow properties allow it to fill complex formwork and congested reinforcement without vibration. This not only simplifies construction, but also reduces labor costs, noise pollution, and vibration related damage. The handbook delves into the mixed design principles for SEC, emphasizing the importance of achieving a high degree of stability to prevent segregation and ensure a homogeneous concrete structure. It also discusses various testing methods used to evaluate the flowability and stability of SEC, ensuring that it meets performance requirements. Next, the handbook covers sprayed concrete,
often used for applications like tunnel linings and slope stabilization. The handbook explains how sprayed concrete is applied using a high velocity stream of air, which propels a mixture of cement, aggregates, and water onto the surface. This method allows a rapid placement of concrete in those challenging environments, even on vertical or overhead surfaces. The handbook delves into the different types of sprayed concrete, including dry mix and wet mix processes, highlighting the advantages and limitations of each approach. It also provides guidance on selecting appropriate equipment, nozzle techniques, and safety precautions for sprayed concrete applications. Now let's explore precast concrete, where elements are cast in a controlled factory setting and transported to the construction site. Precast concrete offers advantages like faster construction times and improved quality control, because elements can be produced in dedicated environments with optimal curing conditions. The handbook explains the different types of precast elements and emphasizes the importance of careful handling and transportation to prevent damage and ensure their integrity upon arrival at the construction site.
It also stresses the need for proper connection details between precast elements to ensure that they function as a cohesive structural system. Having explored these fundamental concrete types, we can move on to some more specialized types, each with its unique properties and applications. We'll begin by looking at fiber reinforced concrete, which incorporates fibers into the mix to enhance its properties.
Fibers, which can be made from materials like steel, glass, or even synthetic polymers, add strength, ductility, and toughness to concrete. Think of them as like tiny reinforcing elements within the concrete matrix, distributing stresses and preventing those large cracks from forming.
That's a great analogy. So instead of one big crack forming, the fibers help create a network of smaller, less impactful cracks.
Exactly. The handbook explains the different types of fibers and their specific benefits, highlighting how they improve the concrete's resistance to cracking, impact, and abrasion. It also discusses the mixed design considerations for fiber reinforced concrete, emphasizing the importance of achieving that proper fiber dispersion and orientation to really maximize their effectiveness.
So it sounds like fiber reinforced concrete is kind of like adding a safety net to the concrete mix, making it more robust and resilient to damage.
That's a good way to put it. Now, let's move on to high strength concrete, which, as its name suggests, exhibits exceptional compressive strength.
I imagine this type of concrete is used in structures that need to withstand those immense loads like skyscrapers or bridges.
You're absolutely right. High strength concrete is often used in high rise buildings, bridges, and other structures that demand that exceptional load bearing capacity. The handbook explains how achieving high strength involves a combination of factors, including a low water to cement ratio, the use of high strength aggregates, and careful curing practices. It also highlights the role of admixtures such as superplasticizers and silica fume in enhancing the strength and durability of high strength concrete.
So it's not just about using stronger ingredients, but also about optimizing the mix design and curing process to really maximize the concrete's potential.
Precisely. Now, shifting gears a bit, let's talk about lightweight concrete, which is often used for applications where weight reduction is a primary concern.
I'm curious, how do you make concrete lighter without compromising its strength?
That's a great question. The secret lies in using lightweight aggregates such as expanded clay, shale, or slate. These aggregates have a porous structure that reduces the overall density of the concrete while still providing adequate strength for many applications. The handbook discusses the different types of lightweight aggregates and their properties, highlighting their benefits for reducing dead loads in structures, improving thermal insulation, and enhancing fire resistance.
So it's like using puffed rice instead of regular rice in a recipe. You get a similar volume, but with less weight.
That's an excellent way to think about it. It's amazing how lightweight concrete can provide both structural and functional advantages, making it a versatile choice for various construction needs.
Now let's dive into a type of concrete that seems almost almost counterintuitive, underwater
Hmm.
concrete. How do you even pour concrete underwater?
Underwater concrete, used for structures like bridge piers, foundations, and marine structures, presents unique challenges. That the concrete mix needs to be designed to prevent washout and segregation as it's placed in that fluid environment. The handbook explains the special considerations for underwater concrete mix design, including the use of high cement contents, anti-washout admixtures, and careful placement techniques. It also highlights the importance of monitoring the concrete's properties and ensuring adequate curing in an underwater environment.
It sounds like underwater concrete construction
Mhm.
requires specialized expertise and meticulous execution
Yeah.
to ensure the integrity and durability of that submerged structure.
Absolutely. Now, let's shift our attention to a type of concrete where aesthetics take center stage.
Yeah.
Architectural concrete.
I've seen some stunning buildings with those exposed concrete surfaces that have a beautiful, almost sculptural quality. I imagine that's architectural concrete.
You're exactly right. Architectural concrete is designed to be exposed as a finished surface, showcasing its texture, its color, and its form. It's often used in buildings, bridges, and other structures where visual appeal is paramount.
Yeah.
The handbook explains the key factors in achieving high quality architectural concrete, including careful formwork selection, precise placement techniques, and meticulous surface finishing. It also highlights the use of admixtures, pigments, and special aggregates to enhance the color, the texture, and the durability of architectural concrete.
It sounds like architectural concrete allows for incredible creativity in concrete construction.
Yeah.
Transforming it from a purely structural material to an aesthetically pleasing design element.
Precisely. Now, circling back to sustainability, let's explore concrete with recycled aggregate.
I'm always interested in learning about sustainable building practices.
So,
Using recycled materials in concrete seems like a great way to reduce waste and conserve resources.
you're absolutely right. Concrete with recycled aggregates incorporates crushed concrete or other recycled materials as a replacement for natural aggregates. This approach promotes sustainability by reducing the need for those virgin materials and minimizing waste. The handbook explains the considerations for using recycled aggregates in concrete, highlighting the importance of assessing their quality, their cleanliness, and potential impact on concrete properties. It also discusses the mix design adjustments that may be necessary when using recycled aggregates, emphasizing the need to ensure adequate strength, durability, and workability.
It's encouraging to see how the concrete industry is embracing sustainability by incorporating those recycled materials into its practices.
Indeed. Now let's shift our focus to energy efficiency and explore insulated concrete forms or ICFs.
ICFs sound intriguing. Can you tell us more about them?
Certainly, ICFs are prefabricated units made from insulating materials such as expanded polystyrene or polyurethane foam, which are used as formwork for concrete walls. The concrete is poured into the ICFs, creating a composite wall system that offers excellent thermal insulation and structural strength.
So it's like building a house with Lego blocks made of insulation and then filling them with concrete.
That's a great way to visualize it. The handbook explains the advantages of ICF construction, including reduced energy consumption, improved sound insulation, and faster construction times. It also provides guidance on the proper design, assembly, and installation of ICFs, ensuring that they meet the required structural and insulation performance standards.
ICF construction seems like a win-win situation. You get a strong and energy efficient building envelope all in one go.
Absolutely. Now, let's move on to a type of concrete that's becoming increasingly popular for its environmental benefits, pervious concrete.
I've heard of pervious concrete, but I'm not quite sure how it works. Can you explain it?
Of course, pervious concrete is a porous pavement material that allows water to infiltrate through it, reducing runoff and promoting groundwater recharge. It's often used in parking lots, sidewalks, and other paved areas where stormwater management is a concern.
So instead of water rushing off the pavement and into storm drains, it soaks into the ground.
Exactly. The handbook explains the unique mix design and placement techniques for pervious concrete, emphasizing the importance of achieving that desired porosity and permeability. It also highlights the environmental benefits of pervious concrete, including reduced stormwater runoff, improved water quality, and reduced heat island effects.
Pervious concrete seems like a fantastic solution for creating more sustainable and environmentally friendly urban spaces.
It certainly is. Now let's shift gears again and discuss mass concrete, which is used in those massive structures like dams and foundations.
I imagine working with such large volumes of concrete presents some unique challenges.
You're absolutely right. Mass concrete refers to large volumes of concrete, typically used in structures like dams, foundations, and retaining walls. It presents unique challenges due to the significant heat generated during the hydration process, which can lead to cracking and other problems. The handbook explains the special considerations for mass concrete mix design, including using low heat cements, temperature control measures, and careful placement techniques to minimize those thermal stresses. It also highlights the importance of monitoring the concrete's temperature during and after placement to ensure it cures properly and avoids that excessive heat buildup.
It sounds like mass concrete construction requires careful planning and execution to manage the challenges associated with those large volumes of concrete and the heat generated during hydration.
Indeed. Now let's move on to another type of concrete used in large scale projects. Roller compacted concrete, or RCC.
I'm not familiar with RCC. Can you tell us more about it?
Certainly, RCC is a dry concrete mix placed and compacted using heavy rollers, similar to how asphalt pavement is constructed. It's often used for dams, pavements, and other applications where the large volumes of concrete are needed, and a relatively rough surface finish is acceptable. And the handbook explains the unique mix design and placement techniques for RCC, emphasizing the importance of achieving that desired compaction and density. It also highlights the advantages of RCC, including its speed of construction, cost effectiveness, and durability.
It sounds like RCC is a practical and efficient solution for those large scale concrete projects where speed and efficiency are paramount.
Precisely. Now, let's turn our attention to high performance concrete, or HPC, a type of concrete that goes above and beyond in terms of its properties.
HPC sounds intriguing. What makes it so special?
HPC is a general term for concrete exhibiting superior properties compared to conventional concrete, such as higher strength, greater durability, and improved resistance to cracking and other forms of deterioration. It's often used in critical infrastructure such as bridges, tunnels, and high-rise buildings where long-term performance and resilience are essential.
So HPC is like the superhero of concrete, stronger, tougher, and more resilient.
That's a great analogy. The handbook explains the key principles of HPC mix design, including the use of high quality materials, low water to cement ratios, and those advanced admixtures to achieve the desired performance characteristics. It also highlights the importance of quality control measures and rigorous testing to ensure that HPC meets those stringent performance requirements.
HPC sounds like a valuable tool for creating durable, resilient, and sustainable concrete structures that can withstand the test of time and the challenges of demanding environments.
Absolutely. Now, shifting gears from new construction to the maintenance of existing structures, let's talk about concrete repair.
I imagine that even the most durable concrete can eventually suffer damage or deterioration over time. What can be done to address those issues?
You're right. Even the best concrete can be affected by various factors. Over time, concrete repair involves addressing damage or deterioration in those existing concrete structures, restoring their structural integrity and extending their lifespan. The handbook provides a comprehensive overview of concrete repair principles and techniques, covering a wide range of issues, including cracking, spalling, corrosion, and chemical attack. It explains the importance of proper diagnosis of the underlying causes of concrete damage, selection of appropriate repair materials, and meticulous execution of repair procedures to ensure long-term success.
Concrete repair sounds like a crucial aspect of maintaining the safety and functionality of our built environment, extending the lifespan of existing structures and minimizing the need for those costly replacements.
Indeed. Now, let's explore a related area, concrete protection.
Concrete protection sounds like a proactive approach to ensuring the long-term durability of concrete structures. What does it involve?
You're exactly right. Concrete protection involves applying coatings or other treatments to concrete surfaces to enhance their durability and resistance to various forms of deterioration. The handbook provides guidance on selecting and applying appropriate protective coatings, considering factors like the type of concrete, the environment, and the specific threats the concrete is exposed to. It covers a range of protective treatments, including waterproofing coatings, anti-carbonation coatings, corrosion inhibitors, and chemical-resistant coatings.
It sounds like concrete protection is a valuable strategy for extending the lifespan of concrete structures, particularly in harsh environments or where the concrete is exposed to aggressive chemicals or other damaging agents.
Absolutely. Now let's discuss a specialized type of concrete construction, shotcrete.
I've heard of shotcrete, but I'm not sure what it is. Can you enlighten me?
Of course, shotcrete, also known as sprayed concrete, involves projecting concrete onto a surface at high velocity using a hose and a nozzle. This method is often used for applications like tunnel linings, slope stabilization, and swimming pools where conventional formwork is difficult or impractical. The handbook explains the different shotcrete processes, including dry mix and wet mix methods, highlighting the advantages and limitations of each approach. It also provides guidance on selecting the appropriate shotcrete equipment, nozzle techniques, and mix designs to achieve the desired results.
Shotcrete seems like a very versatile and efficient concrete construction technique, enabling the placement of concrete in challenging locations and achieving complex shapes and contours.
You're exactly right. Now, let's revisit self-consolidating concrete, or SEC, which we discussed earlier.
I remember you mentioned that SEC flows effortlessly into place without needing vibration. It sounds like a real game changer for concrete construction.
It certainly is. SEC is a highly flowable concrete mix designed to flow into place under its own weight without the need for vibration. This innovative concrete technology offers numerous advantages, including faster construction times, reduced labor costs, and improved concrete quality. The handbook explains the unique mix design principles for SEC, emphasizing the importance of achieving a high degree of stability to prevent segregation and ensure homogeneous concrete structure. It also discusses the various testing methods used to evaluate the flowability and stability of SEC, ensuring that it meets performance requirements.
SEC has revolutionized concrete construction in many ways, making it easier, faster, and more efficient to place high quality concrete in complex forms and congested reinforcement. I'm eager to see how this technology continues to evolve and shape the future of concrete construction.
Me too. Now let's delve into another type of concrete that enhances its properties, fiber reinforced concrete, or FRC.
We discussed fiber reinforced concrete earlier, but I'm always interested in learning more about how fibers can improve concrete's performance.
Certainly. As a reminder, FRC incorporates fibers into the concrete mix to enhance its properties, including tensile, strength, ductility, and toughness. The fibers can be made from various materials such as steel, glass, or synthetic polymers, each offering unique benefits. The handbook explains the different types of fibers and their specific applications, highlighting how they improve the concrete's resistance to cracking, impact, and abrasion. It also discusses the mixed design considerations for FRC, emphasizing the importance of achieving proper fiber dispersion and orientation to maximize their effectiveness.
It's amazing how the addition of these tiny fibers can significantly impact the concrete's overall
Yeah.
performance and durability, making it suitable for such a wide range of applications.
Indeed. Now, let's revisit high strength concrete, or HSC, which we touched upon earlier.
I remember that HSC boasts incredible compressive strength. What are some of the key factors that contribute to its exceptional strength?
As a refresher, HSC is characterized by its exceptional compressive strength, typically exceeding 60 MPa or 8,700 psi. It's often used in high-rise buildings, bridges, and other structures that demand that exceptional load-bearing capacity. Achieving HSC involves a combination of factors, including a low water to cement ratio, using high strength aggregates and careful curing practices. The handbook also highlights the role of admixtures such as superplasticizers and silica fume in enhancing the strength and durability of HSC.
It's fascinating how the careful selection of materials and precise control of the mix design and curing process can lead to such remarkable increases in concrete strength.
Absolutely. Now let's revisit lightweight concrete, which we discussed earlier.
I remember learning about how lightweight aggregates are used to reduce the density of concrete. What are some of the key benefits of using lightweight concrete?
As we discussed before, lightweight concrete is characterized by its reduced density compared to conventional concrete, typically achieved through the use of lightweight aggregates. It's often used for applications where weight reduction is a primary concern, such as roof decks, floors, and precast concrete elements. The handbook explains the different types of lightweight aggregates and their properties, highlighting their benefits for reducing dead loads in structures, improving thermal insulation, and enhancing fire resistance. It also discusses the mix design considerations for lightweight concrete, emphasizing the need to balance strength, durability, and density to meet the specific project requirements.
It's impressive how lightweight concrete can provide both structural and functional advantages, making it a versatile choice for various construction needs.
It certainly is. Now, let's revisit underwater concrete, which we touched upon earlier.
I recall that underwater concrete construction presents unique challenges due to the fluid environment. Can you remind me of some of the key considerations for this type of construction?
Oh, of course. Underwater concrete is used for structures that are cast below the water line, such as bridge piers, foundations, and marine structures. It presents unique challenges due to the fluid environment and the need to prevent washout and segregation during placement. The handbook explains the special considerations for underwater concrete mix design, including the use of high cement contents, anti-washout admixtures, and careful placement techniques. It also highlights the importance of monitoring the concrete's properties and ensuring adequate curing in an underwater environment.
Underwater concrete construction sounds incredibly complex and demanding, requiring a high level of expertise to ensure a successful outcome.
You're absolutely right. Now, let's circle back to architectural concrete, which we discussed earlier.
I remember learning about how architectural concrete is designed to be exposed as a finished surface, showcasing its aesthetic qualities. What are some of the key techniques used to achieve the desired aesthetic effects in architectural concrete?
Architectural concrete is often used in buildings, bridges, and other structures where visual appeal is paramount. The handbook explains the key factors in achieving high quality architectural concrete, including careful formwork selection, precise placement techniques, and meticulous surface finishing. It also highlights the use of admixtures, pigments, and special aggregates to enhance the color, the texture, and the durability of architectural concrete.
It's fascinating how the creative use of formwork placement techniques and surface treatments can transform concrete into a visually stunning and expressive design element.
Indeed. Now, let's revisit concrete with recycled aggregates, which we discussed earlier.
I recall learning about how using recycled aggregates in concrete promotes sustainability by reducing the need for virgin materials. What are some of the key considerations for using recycled aggregates in concrete?
Concrete with recycled aggregates incorporates crushed concrete or other recycled materials as a replacement for natural aggregates. This approach promotes sustainability by reducing the need for virgin materials and minimizing waste. The handbook explains the considerations for using recycled aggregates in concrete, highlighting the importance of assessing their quality, their cleanliness, and potential impact on concrete properties. It also discusses the mixed design adjustments that may be necessary when using recycled aggregates, emphasizing the need to ensure adequate strength, durability, and workability.
It's encouraging to see how the concrete industry is finding innovative ways to incorporate sustainable practices into its operations while still maintaining the high performance and durability of concrete structures.
Absolutely. Now, let's revisit insulated concrete forms, or ICFs, which we discussed earlier.
Right. I remember learning about how ICFs combine insulation and structural strength in a single system. Can you remind me of some of the key benefits of using ICFs for construction?
Of course, ICFs are prefabricated units made from insulating materials such as expanded polystyrene or polyurethane foam, which are used as formwork for concrete walls. The concrete is poured into the ICFs, creating a composite wall system that offers excellent thermal insulation and structural strength. The handbook explains the advantages of ICF construction,
Right.
including reduced energy consumption, improved sound insulation, and faster construction times. It also provides guidance on the proper design, assembly, and installation of ICFs, ensuring that they meet the required structural and insulation performance standards.
ICF construction seems like a very efficient and effective approach to building energy efficient and sustainable structures.
It certainly is. Now let's revisit pervious concrete, which we discussed earlier.
I recall that pervious concrete is a porous pavement material that allows water to infiltrate through it, reducing runoff and promoting groundwater recharge. What are some of the key environmental benefits of using pervious concrete?
Pervious concrete is often used in parking lots, sidewalks, and other paved areas where stormwater management is a concern. The handbook explains the unique mixed design and placement techniques for pervious concrete, emphasizing the importance of achieving the desired porosity and permeability. It also highlights the environmental benefits of pervious concrete, including reduced stormwater runoff, improved water quality, and reduced heat island effects.
Pervious concrete seems like a great way to integrate sustainable practices into our urban landscapes, helping to manage stormwater and mitigate some of the negative environmental impacts of paved surfaces.
Absolutely. Now let's revisit mass concrete, which we discussed earlier.
I remember learning about the challenges associated with mass concrete construction due to the heat generated during the hydration process. Can you remind me of some of the key considerations for managing this heat and preventing problems in mass concrete structures?
Mass concrete refers to large volumes of concrete typically used in structures like dams, foundations, and retaining walls. It presents unique challenges due to the significant heat generated during the hydration process, which can lead to cracking and other problems. The handbook explains the special considerations for mass concrete mixed design, including using low heat, cements, temperature control measures, and careful placement techniques to minimize those thermal stresses. It also highlights the importance of monitoring the concrete's temperature during and after placement to ensure ensure it cures properly and avoids excessive heat buildup.
Mass concrete construction sounds like a very specialized area of concrete technology that requires a deep understanding of the materials behavior and the ability to anticipate and manage potential problems.
You're absolutely right. Now let's revisit roller compacted concrete, or RCC, which we discussed earlier.
I recall that RCC is a dry concrete mix placed and compacted using heavy rollers. What are some of the key advantages of using RCC for construction?
RC is often used for dams, pavements, and other applications where large volumes of concrete are needed and a relatively rough surface finish is acceptable. The handbook explains the unique mixed design and placement techniques for RCC, emphasizing the importance of achieving the desired compaction and density. It also highlights the advantages of RCC, including its speed of construction, cost effectiveness, and durability.
RCC seems like a very practical and efficient solution for large-scale concrete projects where speed and cost effectiveness are important considerations.
Precisely. Now, let's revisit high performance concrete, or HPC, which we discussed earlier.
I remember that HPC exhibits superior properties compared to conventional concrete. Can you remind me of some of the key principles of HPC mixed design and how they contribute to its exceptional performance?
Of course. HPC is a general term for concrete exhibiting superior properties compared to conventional concrete, such as higher strength, greater durability, and improved resistance to cracking and other forms of deterioration. It's often used in critical infrastructure such as bridges, tunnels, and high-rise buildings where long-term performance and resilience are essential. The handbook explains the key principles of HPC mixed design, including the use of high-quality materials, low water to cement ratios, and those advanced admixtures to achieve the desired performance characteristics. It also highlights the importance of quality control measures and rigorous testing to ensure that HPC meets those stringent performance requirements.
It sounds like HPC pushes the boundaries of concrete technology, enabling the construction of more durable, resilient, and sustainable structures.
Absolutely. Now, shifting our focus to another important aspect of concrete construction, joints.
Joints are often overlooked, but I imagine they play a crucial role in the performance and durability of concrete structures. Can you tell me more about them?
You're right. Joints are essential for leaving concrete structures to move and breathe without cracking. Joints are intentional breaks or gaps introduced into concrete structures to accommodate movement and prevent cracking. The handbook provides a comprehensive overview of different types of joints, including construction joints, expansion joints, and control joints. Construction joints are created when concreting is stopped and then resumed at a later time, while expansion joints are designed to allow for expansion and contraction of the concrete due to temperature changes. Control joints are intentionally weakened sections that encourage cracking to occur in a controlled manner, preventing random cracking that could compromise the structure's integrity. The handbook explains the proper design. The handbook explains the proper design and placement of joints, emphasizing the importance of using appropriate joint sealants and water stops to prevent water ingress and maintain that structural integrity of the concrete.
Joints seem like a small detail, but they clearly have a significant impact on the long-term performance and durability of concrete structures.
Absolutely. Now let's turn our attention back to formwork, which provides that temporary mold for shaping concrete.
I remember learning about the importance of selecting appropriate formwork materials and using release agents to prevent the concrete from sticking.
What are some of the other key considerations for formwork design and construction? Formwork plays a crucial role in achieving that desired shape dimensions and surface finish of concrete structures. The handbook emphasizes the importance of selecting appropriate formwork materials, considering factors like the type of concrete, the desired finish, and the structural loads. It also provides guidance on the design, construction, and handling of formwork, ensuring that it can withstand the pressure of fresh concrete and produce that desired shape and dimensions of the structure. The handbook also discusses the use of release agents, which prevent the concrete from sticking to the formwork, allowing for easy removal and achieving a smooth finish. It explains the different types of release agents and their suitability for various formwork materials and concrete types, highlighting the importance of applying them evenly and at the correct rate to avoid defects in the concrete surface. The handbook also emphasizes the importance of proper formwork removal techniques to prevent damage to the concrete and ensure a clean, aesthetically pleasing finish.
It sounds like there's a lot more to formwork than meets the eye, requiring careful planning and execution to ensure a successful outcome.
You're absolutely right. Now let's revisit curing, which is a critical step in concrete production.
I remember learning about how proper curing is essential for maximizing concrete strength and durability. Can you remind me of some of the different curing methods and why it's so important to protect fresh concrete from premature drying and temperature extremes?
Curing involves maintaining adequate moisture and temperature for fresh concrete, allowing for optimal hydration and strength development. The handbook explains the different curing methods, such as covering the concrete with plastic sheeting, applying curing compounds, or misting with water, highlighting the importance of selecting the most appropriate method for the specific project conditions. It also provides guidance on the duration of curing, emphasizing that the concrete needs to be protected from premature drying and temperature extremes, as these can lead to cracking, reduced strength, and diminished durability. Proper curing is essential for maximizing the strength and durability of concrete, ensuring it can withstand the test of time and perform as intended.
It's remarkable how much attention to detail is required at every stage of concrete production, from selecting the right materials to the final curing process.
Absolutely. And the Sika Concrete Handbook does a fantastic job highlighting the key considerations and best practices for achieving high-quality, durable concrete.
Well, it seems we've covered a lot of ground today, exploring the fascinating world of concrete and the wealth of knowledge contained within the Sika Concrete Handbook. From its humble components to its diverse applications and specialized types, concrete is truly a remarkable material that shapes our built environment in countless ways.
It has been a pleasure diving into the intricacies of concrete with you today. The Sika Concrete Handbook serves as an invaluable resource for anyone involved in concrete construction, providing a wealth of knowledge and practical guidance.
From understanding the fundamental principles of concrete technology to exploring the nuances of specialized concrete types and construction techniques, this handbook equips us with the tools to create durable, resilient, and sustainable concrete structures. Whether you're a seasoned engineer or just beginning your journey in the world of concrete, the Sika Concrete Handbook is a valuable companion guiding you toward best practices and helping you navigate the complexities of this remarkable material. So as we conclude our deep dive into the world of concrete, remember that this material is far more than just a simple mixture. It is a testament to human ingenuity, a material that has shaped our civilization and continues to evolve to meet the challenges of the future.
Keep exploring, keep learning, and let this newfound knowledge empower you to create a built environment that is both strong and sustainable.
Thank you for joining us on this journey through the world.
Okay, so today let's dive into something we see every day but don't think much about. Concrete.
Yeah, it's everywhere, right?
Everywhere. Sidewalks, skyscrapers, you name it. We're going deep on this one with a YouTube video called, what was it again? Concrete Technology. Something like that.
That's the one. From Civilians. It's a great channel.
Right, right. So we're going to uncover some cool stuff about this surprisingly complex material.
It's way more interesting than people realize. The history alone goes back thousands of years.
No kidding. I mean, we all know cement is involved, but this video got into the chemistry, tricalcium silicate, dicalcium silicate. Like what?
It's those chemical compounds that actually determine how strong and durable the concrete will be.
It's all about the chemistry.
Right. Take tricalcium silicate, for example. It's responsible for the concrete's initial strength. Imagine building a huge dam. That early strength is crucial.
Makes sense. Got to set that foundation strong, so to speak.
Exactly. And then there's the calcium silicate, which affects the long-term strength, how it holds up over time, decades, even centuries.
So it's like a delicate balance of both the short-term and long-term performance.
Exactly.
Wow. This is making me look at sidewalks a little differently now. But how do they actually make this stuff? This video mentioned giant kilns.
Oh yeah, the process is fascinating. Picture these massive, rotating kilns, heated to over 1400 degrees Celsius. They bake the raw materials in there to create what they call clinker, which is the main ingredient in cement.
It's like baking a cake, but on a massive industrial scale and a lot hotter.
And just as important as the baking itself is the cooling. It has to be cooled down quickly to prevent weaker compounds from forming that would compromise the concrete's strength.
Wow, so it's not just heat, it's precision.
Precisely. And after mixing the concrete, it goes through a bunch of tests to make sure it meets certain standards.
The video talked about compressive strength tests and slump tests. What are those all about?
So the compressive strength test basically measures how much force the concrete can withstand before it crumbles.
Oh wow, they literally crush it.
Pretty much. They want to see how much pressure it can handle. After all, you don't want a bridge collapsing.
Right. What about the slump test?
That one's about workability. Imagine a cone filled with fresh concrete. They lift the cone, and the amount the concrete slumps tells them how consistent it is.
So how much it spreads out?
Yeah, exactly. Too much slump, and it might be too runny, too weak, too little, and it's tough to work with, won't flow properly.
So it's all about finding that Goldilocks zone, not too much, not too little, but just right?
Exactly. And one of the things that influences the slump is the grading of the aggregate.
Okay, hold on. Grading as in rocks getting report cards? I'm lost.
Haha, not quite. We're talking about the size of the rocky material in the mix. There's fine aggregate, like sand, and then there's coarse aggregate, which is more like gravel.
So it's all about the size of the rocks. Who knew?
And the balance between those sizes is really important for getting the right properties in the final product.
So it's like, what's a good analogy? Like mixing a cake, you wouldn't use all flour or all sugar.
Perfect analogy. It's all about getting the proportions right. Speaking of proportions, the video also really emphasized the water-cement ratio.
Yeah, what's that all about? More water equals stronger concrete, right?
That's actually a common misconception.
Yeah.
Too much water actually weakens the concrete, makes it less durable.
Really? That seems counterintuitive.
It's like watering down juice. You might have more liquid, but it's less flavorful, less potent.
Ah, I get it. So it's about finding that balance again, enough water so it's workable, but not so much that it compromises the strength.
Exactly. And here's another thing, even the shape of the aggregate matters. It's not just about size.
Wait, seriously, the shape of the rocks? How does that even make a difference?
Well, think about it this way. Imagine a bucket full of smooth, round marbles. Now imagine a bucket full of jagged, irregular rocks. Which one do you think packs together more tightly?
Probably the jagged rocks.
Exactly. And that's what you want in concrete, a tight interlocking structure. Angular, rough-textured aggregate creates stronger bonds, which means stronger concrete.
So it's like trying to build a tower out of marbles versus a tower out of those interlocking bricks kids play with?
Perfect analogy. Smooth, rounded aggregate might be easier to mix in some cases, but it doesn't create the same level of strength. Again, it's all about finding that balance for this specific application.
I am learning so much today. I had no idea there was so much to consider when it comes to choosing the right aggregate.
And this is just the tip of the iceberg. We haven't even gotten into admixtures, which are like special ingredients that can be added to fine-tune the concrete even further.
Admixtures. This is blowing my mind.
Yeah.
Concrete is way more complex than I ever imagined.
It definitely is. There's a lot more to uncover, so let's get to it. So we've got our concrete mixed, but just like a good cake, it needs time to bake, right?
Right. We were talking about curing.
And it's more than just letting it sit out and dry, isn't it?
Yeah, I'm guessing there's more to it.
It's a whole chemical process called hydration, where the cement reacts with water over time, forming these crystals that bind everything together.
So there's like invisible stuff happening in there, even though it looks solid on the outside.
Exactly. Those crystals are what give the concrete its strength, its durability. Think of it this way. Mixing brings the ingredients together, but curing is where they really bond and become a solid structure.
Ah, I see. It's like the difference between like mixing flour and water versus letting dough rise.
Perfect analogy. And just like letting dough rise, it takes time. The video said curing is as important as mixing, and they weren't kidding. Depending on the type of concrete and the conditions, it can take days, weeks, even months.
Wow, so it's not something you can rush.
Definitely not. It's a gradual process that needs the right conditions, the right moisture, the right temperature.
Too dry, too wet, what happens then?
Too dry, and the hydration process gets messed up. You get weaker concrete. Too much moisture or extreme heat or cold can also cause problems.
It's amazing how much is happening at a microscopic level, turning this mixture into these strong structures we see everywhere. This video has definitely given me a new appreciation for curing.
It's often overlooked, but it's crucial. Now, Remember how we talked about the shape of the aggregate?
Yeah, the whole jagged rocks versus marbles thing.
Well, this video took it even further, talking about admixtures.
Admixtures. Is that like adding spices to your concrete cake?
You could say that. They're basically chemicals added in small amounts to tweak the properties of the concrete.
To tweak them, meaning?
They can do all sorts of things, like they can speed up or slow down the setting time, make the concrete more workable, make it more durable in certain conditions, even change its color.
So it's like customizing it for a specific job.
Exactly. Say you're working on a project in a really cold environment. You might add an air entraining admixture.
Air and training, so you're putting air in the concrete. That doesn't sound good.
It sounds weird, but those tiny air bubbles actually help prevent damage from those freeze-thaw cycles you get in cold climates.
Oh, so it's like insulation for the concrete.
You got it.
Yeah.
Admixtures let engineers adapt concrete for different uses and environments. It's incredibly versatile.
Wow, this is so much more than just mixing cement, sand, and water. I have to ask, with all this talk about materials and processes, what about the environmental impact?
That's a really important question, and it's something scientists are looking into very closely. Cement production does use a lot of energy and contributes to carbon emissions.
So our sidewalks and buildings have a bigger environmental footprint than we realize.
Yeah, to a certain extent. But the good news is there's a big push for more sustainable concrete.
Like what? What are they doing to make it greener?
One exciting area is using things like fly ash and slag byproducts from other industries as part of the mix.
So using waste to make concrete.
Exactly. They're called supplementary cementitious materials, or SCMs. They not only reduce the need for traditional cement, but they can also actually make the concrete even stronger and more durable in some cases.
So less environmental impact and better concrete. That's awesome.
It's a win-win. And this is just one example of how concrete technology is constantly evolving. There's even research into self-healing concrete.
Self-healing concrete? Like, it repairs itself. That sounds like something out of a movie.
It does sound futuristic, but it's based on real science. Researchers are working on adding special types of bacteria to the mix.
Bacteria in concrete.
Yep. These bacteria, they stay dormant until a crack forms. When water gets into the crack, it activates the bacteria. And get this, they actually produce limestone as a byproduct, which fills the crack.
Wait, so the concrete has its own repair crew on standby?
Pretty much. It's still in development, but imagine if concrete could heal itself. It would be a game changer for how long our buildings and roads last.
It's amazing. You'd never think simple concrete could be at the forefront of such incredible innovation.
Exactly. There's always something new to discover.
This has been eye-opening. But before we get lost in a world of microscopic bacteria and self-healing bridges, I want to touch on the human element again.
Good point. We haven't talked much about the people who actually work with this stuff every day.
Right. They don't just pour it and walk away. There's got to be some skill involved in getting it right.
Oh, absolutely. Even with all the technology, you still need skilled workers to place and finish the concrete properly. That's what we can get into next.
So we've talked about the science behind concrete, the chemistry, the ingredients, but let's not forget the people who actually put this stuff in place, right?
Absolutely. Even with all the high-tech stuff we talked about, you still need skilled workers to place and finish the concrete properly.
It's like they're artisans in a way, shaping this raw material into bridges and buildings and everything.
I like that, artisans of concrete. And they use some specialized tools and techniques to get it just right.
The video mentions something called compaction. What's that all about?
Compaction is all about making sure the concrete is as dense and strong as possible.
Okay, so how do they do that?
Basically, it involves removing air pockets that can form in the concrete when it's poured.
Air pockets? Why are those bad?
Think of it like packing a suitcase. You want everything nice and snug.
Yeah, you don't want any empty space.
Exactly. Air pockets in concrete are like empty space. They weaken the structure, make it more prone to cracking.
Ah, so compaction is like squeezing all the air out.
Exactly. They use these vibrating tools that shake and press the concrete, forcing those air bubbles to rise and escape.
Huh. It's like giving the concrete a massage.
Kind of. And it's really important for making sure the concrete cures evenly and reaches its full strength.
It's amazing how much goes into it. You know, I never really thought much about concrete before, but after doing this deep dive, I'm seeing it everywhere.
It's easy to overlook, but it's literally the foundation of our modern world.
Right. Sidewalks, roads, bridges, skyscrapers, none of it would be possible without concrete.
And the thing is, it's not just about the structures themselves, it's about what they represent: human ingenuity, innovation.
Exactly. From the ancient Romans who were using concrete over 2,000 years ago to the scientists today developing self-healing concrete, it's incredible how this one material has shaped civilization.
And it's still evolving. Who knows what amazing concrete innovations the future holds?
Maybe we'll be having this conversation on a self-healing concrete podcasting platform in a few years.
Now that would be something.
Well, until then, I'm definitely going to be looking at concrete a little differently. Thanks for taking this deep dive with me.
My pleasure. It's always fun to geek out about concrete, even if it doesn't sound that exciting.
Okay, so get ready, because today we are diving into the world of concrete. Ever walked down the street and thought, man, I wish I knew more about this sidewalk?
Well, get ready, because we're about to uncover the surprisingly complex world of a material we just totally take for granted.
I know, right? I mean, concrete, it's everywhere, but this module blew my mind. Like, starting with ancient Rome, the Pantheon, there's concrete secrets in there.
Oh, absolutely. The Romans, they were way ahead of their time with concrete. Their secret weapon, volcanic ash.
Volcanic ash. Wait, what?
Yeah, you heard right. They mixed that ash with lime and seawater and boom, they created this super durable concrete mix. I mean, think about it. The Pantheon, it's been standing there for centuries, right? Exposed to the elements and it's still in amazing shape, all thanks to that volcanic ash concrete recipe.
Wow. That's wild. Okay, so what happened after the Roman Empire? Did people just forget about concrete for a while?
Not completely. Concrete use did kind of decline during the Middle Ages, but, and this is important, it was still around. They actually made some really important discoveries back then, like rediscovering hydraulic lime during the Renaissance, a precursor to modern cement. It's like they were setting the stage for, the concrete revolution that was about to happen.
You mean with Portland cement in the 1800s?
Exactly. Portland cement was a total game changer. It's what allowed for mass production of concrete. Suddenly, it was everywhere. And I mean, everywhere. Sidewalks, skyscrapers, you name it.
Speaking of which, this module talks about how concrete is being used today, and some of it is mind-blowing. Homes, skyscrapers, even underwater structures. What's the wildest thing you've seen?
Honestly, where do I even start? One of the most exciting things happening right now is prefabrication. We're talking entire sections of buildings made of concrete, built in factories, and then assembled on site.
Oh, wow. So it's like a giant concrete Lego set.
Yeah. Kind of. It makes construction faster, more efficient, and way less wasteful. And then there's the engineering feats. Like, have you ever seen the Øresund Bridge? It connects Denmark and Sweden.
I haven't.
Oh, it's incredible. They use these massive concrete support pillars, but then sections of it actually float. It's a really amazing example of how versatile and strong concrete can be.
That's amazing. But we also have to talk about the environmental impact. The module did mention eco-friendly concrete.
Right, and that's a really important area of research because traditional concrete production does have a pretty big carbon footprint. So researchers are, trying to find ways to make it better. One way is incorporating recycled materials into those concrete mixtures.
Oh, that makes sense.
Yeah, and another thing they're working on are carbon capture technologies. It's all about minimizing that environmental impact, which is obviously super important.
Absolutely. Okay, so we've talked about the past, the present. Now for the really fun part, the future. Self-healing concrete. Seriously, that's like straight out of a sci-fi movie.
I know, right? But it's getting real. We're talking about embedding sensors in the concrete, right? And these sensors can detect even the tiniest little cracks. And when they do, they release this special repair agent that basically heals the concrete before any real damage can happen.
So in the future, our sidewalks are going to be fixing themselves. That's wild. And what about 3D printing buildings? How close are we to that?
3D printing with concrete is moving so fast. It's not just experiments anymore. We're talking about printing entire buildings, like on demand, which is incredible when you think about affordability, custom designs.
I know. It could totally revolutionize how we build things.
Absolutely.
Wow. Okay, from ancient Rome to self-healing sidewalks, this deep dive into concrete has been eye-opening. Who knew there was so much to learn about this stuff?
Right. It just goes to show concrete, it's more than just what we walk on. It's a technology that's been shaping our world for centuries and will probably continue to do so for centuries to come.
It really makes you think. Like, with all these advancements in concrete, could we build things even taller than the Burj Khalifa? What kind of engineering challenges would that even look like? Hey everyone, and welcome back to the Deep Dive. Today we are going deep into the world of concrete.
Ooh, concrete.
Yeah. And to help us navigate this world, we have the Sika Concrete Handbook. It's like a super detailed guide.
Nice.
Yeah, it covers all the basics, but also dives into some really interesting stuff like sustainability and all sorts of special applications.
Interesting.
So whether you're like planning a big construction project
Oh, cool.
or just kind of curious about concrete.
I'm always curious about concrete.
Yeah, you know, they say curiosity killed the cat.
Hopefully not today.
I know, hopefully not. But anyway, I think this deep dive will give you like a really good foundation in concrete.
Perfect.
So let's jump right in.
Awesome.
What I think is so interesting about concrete is that it's all around us. You know, sidewalks, buildings, bridges.
Yep, it's everywhere.
Exactly. But we kind of just take it for granted.
Yeah,
You
totally.
don't really think about what goes into it or, you know, how it's made.
Right, like it just kind of is.
Yeah, exactly. But when you actually start to dig deeper, it's actually a really fascinating material.
Yeah, it's a lot more complex than people think.
Exactly. And the handbook really emphasizes that. It talks about how modern concrete is made up of 5 key components.
Yeah.
Cement, obviously,
Of course.
water aggregates,
Okay.
admixtures,
Admixtures.
and sometimes supplementary cementitious materials.
Wow, that's a mouthful.
It is.
Mhm.
But the point is that each of these ingredients, they play like a really specific and important role.
I see.
It's a recipe in a way.
Interesting.
And if you change one ingredient, it can have a huge impact on the final product.
So you can't just like throw anything in there.
Exactly. You need to know what you're doing.
Right.
But here's a question for you. With all the focus on sustainability these days, where does concrete fit into all of this?
Yeah, that's a good question. Isn't concrete kind of bad for the environment?
Well, that's kind of the perception.
Right.
Yeah. But the handbook actually dives into this. And it might surprise you to learn that the concrete industry is actually making big strides in sustainability.
Really?
Yeah. And one of the key strategies is using admixtures to actually reduce the environmental impact.
Admixture. So like those ingredients we were just talking about.
Exactly.
Okay, interesting.
Yeah.
I'm curious to learn more about how that works.
Me too. So tell me, how are admixtures making concrete more sustainable?
Well, one of the biggest wins is that admixtures can significantly reduce the amount of cement needed in a concrete mix.
And why is that important?
Well, cement production, it has a pretty hefty carbon footprint.
Ah, I see. So less cement equals less carbon emissions.
Exactly. And there are a bunch of different admixtures that can help with this.
Like what?
Well, for example, super plasticizers. Those are really cool. They basically allow you to use less water in the mix
Okay.
while still keeping the concrete workable.
Workable.
You know, like easy to pour and shape.
Got it.
And because you're using less water, you can also use less cement without sacrificing strength.
Interesting. So it's kind of a chain reaction.
Yeah. Yeah.
Less water, less cement, less carbon emissions.
Yep.
Wow, that's pretty impressive. It's like a small change with big impact.
Totally.
Are there any other ways that admixtures are contributing to sustainability?
Oh, yeah. Absolutely. They can also enable the use of recycled aggregates.
Recycled aggregates. What are those?
Well, think about all the waste that's generated from construction and demolition projects, you know, like concrete, rubble, bricks, that kind of stuff.
Right.
Instead of sending that stuff to the landfill, a lot of it can actually be crushed up and used as aggregates in new concrete.
Oh, that's really cool. So it's like giving those materials a second life.
Exactly, and that reduces the demand for virgin materials, which, you know, saves natural resources.
That makes a lot of sense. So it's not just about what goes into the concrete, but also where those materials come from.
Yeah, definitely.
And the handbook actually has a really great example of this. The Zurich Stadium, they use recycled materials for a lot of the concrete.
Oh, yeah, I read about that. That's a really impressive project.
Yeah. And not only did it save resources, but it also meant that they had to transport way less material to the site.
Which also reduces emissions, right?
Exactly. They actually eliminated something like 6,000 truck trips.
Wow, that's huge.
It is. So it's a really powerful illustration of how sustainable practices can be incorporated into these large-scale projects.
Definitely.
Now, the handbook also mentions something called life cycle assessment.
Life cycle assessment.
Yeah, or LCA.
Oh, okay.
It's basically a way to quantify the environmental impact of a material or product.
Interesting.
Yeah, it takes into account everything from like raw material extraction to production use and even disposal.
Wow, so like the entire life cycle of the concrete.
Exactly.
Yeah.
And it's becoming more and more important in the construction industry.
Why is that?
Well, because it allows us to make more informed decisions. We can compare different materials and choose the ones that have the lowest environmental impact.
That makes sense.
So it's a really valuable tool for designing and building more sustainable structures.
Cool.
So it sounds like the concrete industry is really taking sustainability seriously.
Yeah, it seems like they're making some really positive changes.
Definitely. Now let's dive a little deeper into those 5 concrete components we talked about earlier.
Okay, sounds good.
The handbook describes cement as the binder.
The binder.
Yeah, can you explain what that means?
So when cement comes into contact with water, something really cool happens. There's a chemical reaction called hydration.
Hydration.
And that reaction creates this paste that hardens and binds all the other components together.
Oh, so it's like the glue that holds everything together.
Exactly.
And the most common type of cement is Portland cement, right?
That's right.
And it's made from like pretty basic materials, isn't it?
Yeah, it is. Limestone, marl, and clay. Pretty cool how those common materials can be transformed into something so strong and durable.
It is. Okay, so cement is the glue. What about aggregates? What's their role in this whole concrete puzzle?
So aggregates are kind of like the building blocks of concrete.
Okay.
They make up the bulk of the volume and they give the concrete its strength and stability.
So what kinds of materials are we talking about here?
Mostly things like sand, gravel, and crushed stone.
Oh, okay, so basically rocks.
Pretty much. But it's not just about throwing any old rocks in there. The handbook talks about the importance of the aggregate mix's particle size distribution.
Particle size distribution.
Yeah, it's about how the different size particles fit together. You want to achieve the optimal packing density to create a strong and durable concrete structure.
So it's not just about the type of aggregates, but also how they all fit together.
Exactly. It's like a giant 3D puzzle.
Wow, I never thought about concrete like that. And of course, using recycled aggregates adds another layer of complexity.
Yeah, for sure. You have to make sure the recycled materials meet certain quality standards.
And of course. Okay, so we've got cement, the glue,
Mhm.
and aggregates, the building blocks. What about water? It seems like the simplest ingredient.
Yeah, water, it seems so basic, right?
Yeah.
But the handbook stresses that the quality of the water used in concrete is actually really important.
Really?
Yeah, it needs to be clean and free of contaminants.
Contaminants like what?
Well, things like salts, oils, or even just excessive amounts of organic matter.
And why are those a problem?
They can interfere with the hydration process, that chemical reaction we were talking about earlier.
Right.
And that can mess up the properties of the concrete.
Oh, I see. So it's not just any water will do.
Definitely not. And the amount of water is important too.
Okay, how so?
Well, there's something called the water cement ratio, or WC ratio for short.
Okay.
And this ratio, it directly impacts the strength and durability of the concrete.
So too much water would weaken the concrete.
Exactly. But too little water can make the concrete difficult to work with.
So it's about finding that sweet spot.
Yeah, exactly.
The handbook goes into detail about how to actually calculate the effective water content, taking into account all sorts of factors, like the water absorbed by the aggregates.
Yeah, it can get pretty technical.
It sounds like it. So let's move on to admixtures, those secret ingredients that are helping make concrete more sustainable.
Ooh, yes, admixtures, they're like the magic touch.
Yeah, the handbook lists like a whole bunch of them, each with its own specific function.
It's amazing how they can tweak the properties of concrete in so many different ways.
It is. Can you give us like a quick rundown of some of the most impactful ones?
Sure. So we talked about super plasticizers earlier, that those are the ones that help reduce the water content.
Right.
And that leads to lower cement usage and lower carbon emissions.
Fantastic. Any others?
Then there are set accelerators and retarders. Those are kind of like time benders for concrete.
Time benders.
Well, set accelerators, they speed up the hardening process. And retarders, they slow it down.
Oh, interesting. Why would you want to slow it down?
Well, in hot weather, for example.
Oh, okay.
The concrete might set too quickly, which can make it difficult to work with.
Right.
So a retarder can give you more time.
That makes sense. Any admixtures that help with durability?
Absolutely. Air and training agents, those are really important for improving freeze-thaw resistance.
Freeze-thaw resistance.
Yeah, so in colder climates,
Okay.
water inside the concrete can freeze and expand, which can cause the concrete to crack and break down.
Ah, that makes sense.
But air and training agents, they create tiny air bubbles inside the concrete.
Oh, cool.
And these bubbles, they act like little shock absorbers when the water freezes.
Interesting. So it's like giving the concrete some breathing room.
Exactly. And those air bubbles help protect the concrete from damage.
So it's like a built-in safety feature.
Pretty much. And then there are water-resisting admixtures.
I know.
Those are all about keeping the concrete dry.
Ah, so like waterproofing.
Yeah, exactly. They reduce the concrete's permeability, which means it's harder for water to seep in and cause problems.
Problems like what?
Well, things like cracking, staining, corrosion of the reinforcement.
Oh, wow.
Water can really wreak havoc on concrete over time.
Right, of course. So it sounds like admixtures, they're kind of like a Swiss Army knife for concrete.
I like that analogy. They really can do so much.
They can, but I imagine you have to use them carefully, right?
Oh, yeah, absolutely. Dosage is crucial. Too much or too little of a particular admixture can throw off the balance and actually have a negative impact on the concrete.
So it's all about finding that right balance.
Always.
Now, the handbook also talks about concrete mix design.
Mix design.
Yeah, basically figuring out the right proportions of all those ingredients.
Oh, okay.
Cement, water, aggregates, admixtures, the whole shebang.
Sounds complicated.
It can be,
Hmm.
but it's super important because the mix design ultimately determines the properties of the hardened concrete.
So it's not just a matter of throwing everything together.
No, definitely not. It's a science, and there's a lot of thought that goes into it.
I see.
Like, for example, the water-cement ratio we talked about earlier,
Mhm.
that plays a huge role in determining the strength of the concrete.
Okay.
But other factors are important too, like the type of aggregates you use, the specific admixtures, the curing conditions, all that stuff.
So how do you even figure out the right mix design?
Well, there are established guidelines and standards, but each project also has its unique requirements.
All right, of course.
So it's a combination of experience, knowledge, and using the right tools.
What kind of tools?
Well, the handbook actually mentions a software called the Sika Mix Design Tool.
Oh, cool.
Yeah, it basically helps you calculate the optimal mix proportions based on all the specific needs of your project.
That's pretty handy.
It is. And one thing that's important to remember is that achieving a specific concrete strength isn't always about just adding more cement.
Really?
Yeah, sometimes using less cement and optimizing the other components can actually lead to stronger and more durable concrete.
Interesting. So it's about finding that balance again.
Exactly.
Like a delicate dance.
It is. Now, once you've got your mix design figured out,
Yeah.
you need to make sure that the fresh concrete actually meets those specifications.
Right.
And that's where testing comes in.
Ah,
The
okay.
handbook talks about a bunch of different tests that are done on fresh concrete to make sure it's good to go.
What kind of tests?
Well, one of the most basic ones is the slump test.
The slump test.
Yeah, have you ever seen that one?
I don't think so.
So they basically fill this cone-shaped mold with concrete,
Okay.
and then they lift the mold up and they see how much the concrete slumps down.
Oh, interesting.
And the amount of slump it tells you about the workability of the concrete.
Workability.
Yeah, basically how easy it is to pour and shape and compact the concrete.
Ah, I see. So you want a certain amount of slump. Not too much, not too little.
Exactly. Another important test is the air content test.
Okay.
Remember how we were talking about air and training admixtures?
Yeah, those tiny air bubbles.
Exactly.
Hmm.
Well, this test measures how much air is actually trapped in the mix.
So you can make sure you have enough of those little shock absorbers.
Exactly. And then there's the bleeding test.
Bleeding.
Yeah, it sounds kind of gruesome,
It does.
but it's not that bad. It basically just measures the tendency of water to rise to the surface of the concrete.
Oh, okay.
And too much bleeding can weaken the surface and cause problems later on.
That makes sense.
They also test the temperature of the fresh concrete because that can affect how quickly it sets.
Interesting.
So yeah, there are a lot of different tests that are done to make sure the concrete is up to snuff.
So they really take quality control seriously.
They do, and for good reason.
Yeah, of course.
Now, once the concrete is placed and it hardens, there are even more tests that are done to evaluate its quality.
Oh, okay. Like what?
Well, the most common one is the compressive strength test.
Compressive strength.
Yeah, basically it measures how much force the concrete can withstand before it crumbles.
Oh, wow. So like how strong it is.
Exactly. They also do tests to measure flexural strength, which is the concrete's ability to withstand bending.
And why is that important?
Well, it's especially important for things like pavements and beams.
Right.
Anything that's going to be subjected to bending forces.
Makes sense.
They also look at Young's modulus of elasticity, which sounds really fancy.
It does.
But it's basically just a measure of how stiff the concrete is.
So like how much it deforms under load.
Exactly.
Interesting.
So yeah, all these tests help ensure that the concrete is going to perform as intended.
It's good to know that there are so many checks and balances in place.
It is. Now let's move on to the exciting part.
What's that?
Concrete applications. The handbook talks about all the amazing ways concrete is used in construction.
Oh, cool. Yeah, I'm curious about that.
It's really incredible. It's used in everything from sidewalks to skyscrapers to dams to bridges.
Wow.
And one way to kind of break down all these different applications is to look at the different methods of concrete placement. Because the method you choose often dictates things like the type of mix design you need and the specific challenges you'll face.
I see.
So let's start with the classic crane and bucket concrete.
Crane and bucket.
Yeah, it's like the OG of concrete placement.
Okay.
It's simple, it's versatile, it's suitable for most concrete types.
So like a good all-rounder.
Exactly. But it's not the most efficient method for large volumes of concrete
Right.
or for projects with really complex shapes.
I can imagine.
So for those larger projects, pumped concrete is often a better choice.
Pumped concrete.
Yeah, they basically pump the concrete through hoses.
Oh, okay.
And it can be placed with a lot of precision.
Cool.
So it's really good for like high rises or bridges or any project where you need to place a lot of concrete quickly and accurately.
That makes sense.
But the mix design for pumped concrete is really important.
How so?
Well, it can't be too stiff or it won't flow through the hoses properly.
Oh, right.
But it can't be too wet either,
Right.
or it could segregate.
Oh.
Yeah, basically the different components of the concrete separate, which weakens the concrete.
Ah, okay.
So it's about finding that sweet spot. Again, not too thick, not too thin.
The Goldilocks of concrete mixes.
Exactly. Now, the handbook also mentions something called self-compacting concrete, or SCC.
Self-compacting concrete.
Yeah, it's pretty cool.
How so?
Well, as the name suggests, it basically compacts itself.
What?
Yeah, it flows really easily into complex shapes and around dense reinforcement without needing any vibration.
Wow. That sounds like magic.
It kind of is. It's a really innovative type of concrete.
So what's the catch?
Well, it does require careful mix design and formwork considerations.
Yeah.
And it's usually more expensive than conventional concrete.
Okay.
But for certain applications, the benefits can really outweigh the costs.
Right. So like when you have those really complex shapes or tight spaces.
Exactly. Now, the handbook also talks about some other cool applications like mass concrete
Mass.
and roller compacted concrete that's used for things like pavements and dams,
Interesting.
and even sprayed concrete, which is shotcrete.
Shotcrete.
Yeah, it's used for stabilizing slopes and tunnels.
Wow. Concrete is so versatile.
It really is. It's used in so many different ways.
Amazing. Now I'm curious about those special concrete types we touched on earlier, like waterproof concrete. How do they actually make concrete waterproof?
That's a great question. Achieving waterproof concrete, it's a multifaceted approach.
Here.
It starts with the mix design.
Okay.
They use special water-resisting admixtures that help reduce the permeability of the concrete.
Permeability.
Yeah, basically how easily water can pass through it.
Got it.
So these admixtures, they kind of block the pores and capillaries in the concrete, making it much harder for water to penetrate.
So it's like creating a tighter seal.
Exactly. But it's not just about the mix itself.
Right.
Construction practices are really important too.
Like what?
Well, for example, making sure that all the joints are properly sealed
Okay.
and curing the concrete thoroughly.
Ah, curing.
We'll talk about that more in a bit.
Okay.
But yeah, it's a holistic approach. You need to get everything right to achieve a truly waterproof structure.
Makes sense. Now, what about corrosion-resistant concrete?
Corrosion-resistant concrete. That's another important one.
Yeah, especially when you're dealing with steel reinforcement,
Exactly. Corrosion can be a major problem.
especially in harsh environments, right?
Right, like coastal areas where there's a lot of salt in the air.
Or places where they use de-icing salts on the roads.
Exactly. So how do they protect the steel from corrosion?
Well, the handbook talks about several strategies.
Okay, like what?
One approach is to use corrosion-inhibiting admixtures.
Ah, okay.
They basically create a protective layer around the steel.
So it's like giving the rebar its own little raincoat?
Pretty much. Another strategy is to ensure there's sufficient concrete cover over the reinforcement.
Concrete cover.
Yeah, basically the thickness of the concrete layer that surrounds the steel. The thicker the cover, the harder it is for corrosive agents to reach the steel.
It's like a shield.
Exactly. And they also use special coatings and sealants to further protect the concrete.
Interesting. Now let's talk about frost and freeze-thaw resistance.
Ooh, yeah, that's a big one in colder climates.
It is. So what makes concrete susceptible to damage from freezing temperatures?
Well, when water freezes, it expands, right?
Right.
And that expansion can create a lot of pressure inside the concrete,
Okay.
which can lead to cracking and spalling.
Spalling.
Yeah, that's when pieces of the concrete surface start to break off.
Oh, yikes.
Yeah, it's not good.
So how do you prevent that?
Well, remember those air entraining admixtures we were talking about earlier?
The tiny air bubbles?
Exactly. Those air bubbles, they actually provide space for the expanding ice to go.
Oh, I see.
So instead of putting pressure on the concrete, the ice can just expand into those air voids.
That's really clever. So it's like giving the ice crystals a place to stretch out.
Exactly. But it's not just about the air bubbles.
Oh, but what else?
Using frost-resistant aggregates is really important too.
Okay.
Some aggregates are more porous than others, meaning they can absorb more water,
Right.
and that water can freeze and cause damage.
I
So
see.
you want to use aggregates that are less porous and less likely to absorb water.
Makes sense.
And of course, proper curing is essential as well.
Curie.
Yeah, we'll talk about that more later.
Okay.
But basically, when concrete is cured properly, it develops a stronger and denser structure, which makes it more resistant to all sorts of damage, including freeze-thaw damage.
Got it. Okay, let's move on to sulfate resistance.
Sulfate resistance.
Yeah, it's kind of a mouthful.
It is.
But it's an important one, especially for structures that are exposed to sulfates.
Sulfates.
Yeah, they're naturally occurring compounds that can be found in soil and groundwater.
Oh, okay.
And when sulfates react with certain components of the cement, it can cause the concrete to expand and crack.
Oh, wow.
Yeah, it's not good.
So how do you prevent that?
Well, one way is to use sulfate-resistant cements.
Ah, okay, so they're specially formulated to resist sulfates.
Exactly. And limiting the water-cement ratio is important too.
Oh, right, because a lower water-cement ratio means a denser concrete.
Exactly. And a denser concrete is less permeable, which means it's harder for the sulfates to penetrate and react with the cement.
That makes sense. So it's all about creating a barrier.
Pretty much. And the handbook also mentions a bunch of other special concrete types.
Oh, cool. Like what?
Well, there's fire-resistant concrete,
Okay.
abrasion-resistant concrete.
Abrasion resistant.
Yeah, so like for surfaces that are going to experience a lot of wear and tear.
Oh, okay.
And chemical-resistant concrete.
So like for industrial applications.
Exactly.
Wow, concrete really can be tailored to meet so many different needs.
It really can. It's such a versatile material.
It is. Now, what about this white box construction thing?
A white box construction, that's a really interesting concept.
What is it?
It's basically a holistic approach to building watertight structures.
Watertight structure.
Yeah, like basements and underground parking garages, that kind of thing.
Yeah, okay.
And it goes beyond just using waterproof concrete.
Okay, so what else is involved?
Well, it's about considering every aspect of the design and construction process
No.
to minimize the risk of water intrusion.
So it's like a whole system.
Exactly.
Yeah.
And it starts with controlling crack formation.
Crack formation.
Yeah, because cracks are like highways for water to get in.
Right.
So they use techniques to minimize shrinkage, which is one of the main causes of cracking.
Oh, okay.
They also use proper jointing techniques to accommodate movement and prevent cracking.
Interesting.
And they pay very close attention to concrete placement and compaction to make sure there are no voids or air pockets that water could seep into.
So it's about creating a really solid and dense structure.
Exactly. And curing is also super important.
Curing.
Yeah, basically it's the process of keeping the concrete moist and at the right temperature while it hardens. And this allows the concrete to hydrate properly and develop its full strength and durability.
Ah, I see.
So yeah, white box construction, it's a really comprehensive approach to waterproofing.
Sounds like it. Now, what about some general best practices for concrete construction? The handbook mentions mold release agents.
Mold release agents. Those are essential for preventing the concrete from sticking to the forms.
The forms.
Yeah, you know, the molds that they pour the concrete into.
Oh, right, of course.
So these mold release agents, they create a barrier between the concrete and the formwork so that the concrete can be easily removed once it's hardened.
I see. And are there different types of mold release agents?
Yeah, there are. And choosing the right one depends on the type of formwork material you're using and the desired finish of the concrete surface.
Okay.
And the handbook stresses the importance of applying the release agent evenly and sparingly.
Why sparingly?
Well, too much release agent can actually cause problems with the concrete surface.
Oh, interesting.
So it's all about finding that balance again.
Oh, got it. Now, what about concrete placement? Any tips for ensuring a successful pour?
Well, one of the biggest things is to avoid segregation.
Segregation.
You remember when we talked about how the different components of the concrete can separate?
Oh, right.
Well, that can happen during placement if you're not careful.
I see.
So the handbook talks about different techniques for pouring the concrete in a way that minimizes segregation.
Okay.
And they also talk about controlling falling heights.
Falling heights.
Yeah, basically how far the concrete is allowed to drop from the bucket or the hose into the formwork.
Okay.
Because if the concrete falls too far, it could segregate.
Right.
And they talk about roughening the joint surfaces.
Joint surfaces.
Yeah, so when you're pouring concrete in sections, you want to make sure that the concrete from the previous pour bonds properly with the new concrete. So rough it up the surface to create a better bond.
That makes sense. What about vibration?
Vibration, that's super important.
Like, why is that?
Well, it helps to compact the concrete and remove any trapped air.
Oh, okay.
And that's crucial for achieving the desired strength and durability.
So you want to get rid of all those air pockets.
Exactly.
Yeah.
And the handbook emphasizes the importance of using the right type of vibrator for the job
Okay.
and vibrating for the correct amount of time.
Why is the time important?
Well, if you don't vibrate enough, the concrete won't be properly compacted.
Right.
But if you vibrate too much, it can actually weaken the concrete.
Oh, wow. So it's about finding that sweet spot again.
Always. And then there's finishing.
Finishing.
Yeah, basically smoothing and shaping the surface of the concrete.
Okay.
And there are a bunch of different techniques that can be used depending on the desired look and feel.
I can imagine.
And the handbook talks about the use of finishing aids, which can help achieve specific effects.
Like what?
Well, for example, you can use a broom finish to create a non-slip surface,
Oh, okay.
or a trowel finish to create a smooth surface. And they also talk about stamping, which is a way to create decorative patterns in the concrete.
Cool.
And last but not least, there's curing.
Curing.
Yes, curing.
This is the keeping it moist thing.
Exactly.
Yeah.
It's one of the most important steps in the entire process.
Okay. All ears.
So basically, curing is all about controlling the moisture and temperature of the concrete while it hardens.
Okay.
And this allows the concrete to hydrate properly and develop its full strength and durability.
So why is it so important?
Well, if the concrete dries out too quickly, it can crack and it won't be as strong as it should be.
Oh, I see.
And if it gets too hot or too cold during the curing process, that can also cause problems.
Makes sense. So how do they actually cure concrete?
Well, there are a bunch of different methods.
Okay.
One common one is to simply cover the concrete with plastic sheeting or burlap sacks.
Oh, okay.
That helps to trap moisture and prevent it from evaporating too quickly.
Right.
And they also use curing compounds, which are liquids that are sprayed onto the surface of the concrete.
And what do those do?
They form a membrane that prevents the concrete from drying out.
Interesting.
And for large horizontal surfaces like pavements, they often use water curing.
Water curing.
Yeah, they basically just flood the surface of the concrete with water.
Oh, okay.
And that keeps it nice and moist.
So it's like giving the concrete a nice long bath.
Exactly. And the handbook emphasizes that the curing method you choose should be based on the type of concrete, the environmental conditions, and the specific requirements of the project.
Right.
So it's not a one-size-fits-all kind of thing.
I see.
But yeah, curing, it's a crucial step that can't be overlooked.
So curing is all about giving the concrete the time and the right conditions to reach its full potential.
Exactly. It's like nurturing a delicate plant.
Yeah.
You got to give it what it needs to thrive.
That's a great analogy. It really is. Like giving it the TLC it needs.
Totally. You know, it's amazing how much we rely on concrete in our everyday lives.
Yeah.
Yet we hardly ever think about it.
Yeah, it's kind of invisible in a way.
It is. But after this deep dive, I have a whole new appreciation for it.
Me too.
It's such a complex and fascinating material.
It is. And speaking of complexity, the handbook talks about concrete standards.
Standards. They might not be the most glamorous topic, but I know they're important.
They are. Think of them as the rule book for concrete.
Okay.
They lay out all the guidelines and requirements for everything from the materials themselves to the testing methods to the performance of the finished product.
So it's all about ensuring consistency and quality.
Exactly. Standards help ensure that concrete is safe, durable, and performs as expected.
So it's like a quality control system for the entire industry.
Pretty much. And the handbook mentions a few key standards.
Okay, like what?
Well, in Europe, there's EN 206-1. That's like the main standard for concrete.
Okay.
It covers a wide range of things like mixed design properties and testing methods.
So it's like the Bible of European concrete?
You could say that. And then there's EN 9342. That one specifically focuses on admixtures. It defines the different types of admixtures and outlines performance requirements.
So that ensures those admixtures are actually doing their job.
Exactly. And it helps to harmonize practices across different countries and regions.
Now, are there any global standards for concrete?
Yeah, the handbook also mentions ASTM standards.
Yes, yeah.
It stands for the American Society for Testing and Materials.
Okay.
and they develop standards that are used all over the world, not just in the US.
So it's like a common language for the concrete industry.
Pretty much.
That makes a lot of sense.
Yeah.
It's important to have those clear guidelines, especially when you're dealing with a material that's as critical as concrete.
Absolutely. Standards help ensure that we're building structures that are safe and reliable.
Well, we've covered a lot of ground in this deep dive. From the basic components of concrete to sustainable practices to specialized applications and even the importance of standards.
It's been quite a journey.
It has. I feel like I've learned so much.
Me too. Concrete is a lot more interesting than I thought.
Right. It's easy to take it for granted, but it really is the foundation of our built environment.
It is, and it's constantly evolving.
That's what's so exciting about it.
Mm.
So before we wrap up, let's leave our listeners with a little something to think about.
Sounds good.
We talked about how the concrete industry is becoming more sustainable. What innovations do you think we'll see in the future?
Ooh, that's a tough one. But I think we'll definitely see more advancements in admixtures, things that allow us to use even less cement and reduce the carbon footprint even further.
Right. Maybe even cements that are carbon neutral or even carbon negative.
Yeah. Or maybe concrete that can actually absorb CO2 from the atmosphere.
Wow. That would be amazing.
It would, like turning buildings into giant air purifiers.
Exactly.
Yeah.
So yeah, the future of concrete, it's looking pretty bright.
It is. It's an exciting time to be in the concrete world.
Well, that's all the time we have for today's deep dive.
Already.
I know it flew by. But don't worry, we'll be back soon with another fascinating topic to explore.
Can't wait.
In the meantime, if you're interested in learning more about concrete, be sure to check out the full Sitka Concrete Handbook. It's a wealth of information.
It is. And there are tons of other resources available online too.
So keep those brains churning, and we'll catch you on our next deep dive.
See you then.
Until then. Hey everyone, welcome back for another deep dive. Today we're talking about concrete, but not just any concrete. We're going deep into the world of specialized concrete.
Yeah, we always say concrete is everywhere, but it's really incredible when you think about all the different ways we can engineer it for different and difficult applications.
Definitely. And that's what makes this so fascinating, right? It's about taking this material we think we know and then seeing how it's being pushed to its absolute limits.
Exactly. It really showcases human ingenuity.
So are you ready to jump into the world of like high strength mixes and self-healing structures?
Let's do it. I think anyone who's driven over a pothole recently can get behind the idea of self-healing concrete.
That's for sure. All right, so let's start with the heavy hitter, so to speak. High strength concrete. What makes this type of concrete so special?
Well, think about the Burj Khalifa, one of the tallest buildings in the world. That kind of height is only possible because of high strength concrete.
It's mind-boggling how they actually make it strong enough to support that kind of weight. Is it just like more cement?
It's more than that. It's about adding what we call supplementary cementitious materials, or SCMs, things like fly ash and slag.
SCMs, okay, so like secret ingredients for super concrete.
You could say that. They basically react with the cement to create a denser, stronger material.
Okay, so from super strong, we move on to super light, lightweight concrete.
Right. And it's not that it's not strong, it's just, lighter. This is super helpful when you're worried about the weight of a structure. Think of things like roof gardens or balconies.
Makes sense. So you don't want a heavy concrete slab weighing everything down.
Exactly. It's about finding that balance between strength and weight. Like, you wouldn't want to carry around a whole stack of encyclopedias if you could have all that info on a lightweight tablet, right?
Great analogy. Now, onto something that sounds almost too good to be true. Self-healing concrete.
Right. It sounds like something out of a sci-fi movie.
It really does. So how does it actually, heal itself?
Well, there are a couple of ways. One is to use bacteria that produce limestone. When a crack forms and water seeps in, the bacteria become active and literally seal the crack.
No way. So it's like the concrete has its own immune system?
Pretty much. Another method uses microcapsules filled with a healing agent. When the concrete cracks, the capsules break open and release the agent, which then hardens and fills the crack.
That's incredible. I imagine this is a game changer for structures like bridges and tunnels where repairs are super disruptive and expensive.
Absolutely. And don't forget underwater structures where repairs are even more challenging.
Okay, so moving on to another type of specialized concrete, fiber reinforced concrete, or FRC. What can you tell us about this one?
Well, as the name suggests, it involves adding fibers to the concrete mix. These fibers can be steel, glass, or even synthetic materials.
So it's like reinforcing the concrete from the inside out.
Exactly. The fibers act like tiny little reinforcing bars, which dramatically increases the concrete's tensile strength and its ability to resist cracking.
So where would you typically use this type of concrete?
You'll often find it in industrial floors that need to withstand heavy loads, like in factories and warehouses. It's also used in roads and bridges to make them more durable.
So this is the super tough concrete. And then we have ultra high performance concrete, which is what? Even tougher.
Think of UHPC as the ultimate concrete. The one you use when failure is simply not an option. It's incredibly strong and durable. We're talking bank vaults, nuclear containment structures, that kind of thing.
Wow, okay. That definitely sounds ultra high performance.
And the applications reflect that. It can even be used in bridges with longer spans, reducing the need for as many supporting piers.
That's amazing. It seems like the possibilities with concrete are almost endless, but of course we have to consider the environmental impact.
You're right. Traditional concrete production does have a significant carbon footprint, but that's why we have things like permeable concrete, which is designed to be more sustainable.
Right. Permeable concrete, I've seen that around. It's the one that lets water soak through it, right?
Right. Exactly. It helps to reduce runoff and prevent flooding. Plus, it can help to replenish groundwater supplies. It's a great example of how we can engineer concrete to be more environmentally friendly.
So from self-healing skyscrapers to eco-friendly pavements, it's amazing to see how concrete technology is evolving.
Absolutely. And who knows what incredible innovations are on the horizon for this versatile material.
I can't wait to find out. Thanks for joining us for this deep dive into the world of specialized concrete. All right, so today we're doing something a little different.
Different in a good way, I hope.
Definitely. It's still about digging deep into a fascinating topic. But we're going to get up close and personal with something you see literally everywhere. Concrete.
Ah, concrete. The stuff of sidewalks and skyscraper.
Exactly. But here's the thing. Most people don't think twice about it. It's just there. But what we're interested in is the hidden world behind that deceptively simple surface.
It's way more exciting than it sounds, trust me.
Right. Because behind every sturdy bridge, every towering building, there's a whole lot of science and engineering going on to make sure those structures can actually withstand the test of time.
It's not magic, it's meticulous quality control.
Exactly. And that's our deep dive for today. We're going behind the scenes to uncover the secrets of concrete quality control. How do engineers guarantee that what seems like a simple mix of rocks and water can support massive structures and stand strong for decades?
Well, for starters, it's more than just rocks and water. But you're right, the journey from raw materials to a finished structure is pretty amazing.
So let's start there. What are we even working with? What goes into this magical mix?
Well, magical mix might be pushing it, but it is a fascinating interplay of components.
I mean, I'm picturing like a giant cement mixer and someone tossing in whatever they can find.
Thankfully, it's a bit more precise than that. It all starts with the core ingredients, and the first one, the most crucial one, is cement.
Okay, so cement, the glue that holds it all together.
Exactly. Think of it as the binder. But just like you wouldn't use any old glue for every single project, the type of cement matters.
So we're talking about different grades, different strengths.
Absolutely. And different compositions too, because depending on where the concrete's being used, it might need to resist things like sulfate attacks, especially in areas with high sulfate content in the soil or water.
So the environment plays a role too. It's
Right.
not one size fits all.
Not at all. Then you've got your aggregates. Now, these are the real rocks you were thinking of: sand, gravel, crushed stone. They give the concrete its bulk, its mass, and again, the size and type of these aggregates can dramatically affect the final product.
Interesting. So it's like choosing the right type of flour for baking. Depending on what you want to bake, a cake or bread, you choose your ingredients carefully.
Perfect analogy. And to round it all off, you might have special additives in the mix. These are the secret ingredients. Want concrete to set faster, there's an additive for that. Need it to withstand freezing temperatures. Additive. Even changing the color, there's an additive for that.
Wow, so it's like a chemistry set, almost endless possibilities depending on what you add in.
Yeah.
But even with the perfect ingredients, if you don't mix them properly,
You're headed for disaster. You've got it. Even the best ingredients in the world won't magically make perfect concrete on their own. That's where testing comes in. And it happens at multiple stages, kind of like quality checkpoints throughout the process.
makes sense. So you've got your raw materials all laid out. What's the first test? Are we building a concrete castle in a lab somewhere?
Ah, I wish. No, the first round of tests is all about the fresh concrete, right after it's mixed. We need to ensure it has the right consistency and workability before it starts hardening.
I see. Because once it sets, you can't really mold it anymore.
Exactly. One of the most common tests we do at this stage is the slump test.
Slump test sounds descriptive.
It is. We basically fill this cone-shaped mold with the fresh concrete, then carefully lift the mold away. How much the concrete slumps or spreads out tells us a lot.
So too much slump, and it's like pancake batter too runny.
Right. Not enough. And it's like trying to spread cold peanut butter, difficult to work with.
Makes sense. So we've ensured our concrete has the right consistency, but the testing doesn't stop there, right?
Not even close. Once the concrete hardens, we move on to a whole other battery of tests to measure its strength and overall integrity.
I imagine this is where things get a bit more destructive.
You could say that. The classic test, the one everyone imagines, is the compressive strength test. We're talking about putting immense pressure on concrete cylinders until they literally crumble.
Talk about a high-stakes stress test.
Yeah,
But I'm guessing that's not the only way to check for strength.
you're right. We've also got non-destructive testing methods, which are pretty amazing when you think about it.
How so?
Well, these methods let us peer inside the concrete without actually breaking anything.
Like concrete x-rays?
Kind of. One technique uses ultrasonic pulse velocity. We send sound waves through the concrete and measure how fast they travel. Cracks, voids, anything off. The sound waves will tell us.
So it's like giving the concrete a health checkup without any invasive procedures.
Exactly. And the best part is, this information helps us make sure the concrete is structurally sound and meets all the necessary standards.
Which is the whole point. Speaking of the process, we've talked about the before with testing the fresh concrete and the after with testing the hardened concrete. But what about the in-between? You mix up this giant batch of concrete. What happens next? It's not as simple as just pouring it into a mold and hoping for the best, right?
You're right. There's a lot that happens between mixing and the final product. We've got to think about transporting the concrete to the construction site, making sure it doesn't start setting too soon, or worse. Segregation, it's the concrete nightmare. Imagine your ingredients separating before you've even had a chance to bake that cake. Not good.
Not good at all. So how do you prevent something like that?
Careful transportation is key. Think special trucks designed to keep the concrete churning gently as it's being transported. Then there's the actual pouring process, which is another art form in itself.
I bet you've got to make sure it goes in evenly, right? No air pockets or weak spots.
Exactly. And even after it's poured, the process isn't over. We gotta talk about curing.
Curing, like what you do with a nice salami.
Not quite, though there are parallels with aging and developing flavors, but in concrete's case, curing is about controlling the moisture and temperature. This allows the cement to properly hydrate and reach its full strength potential.
So it's not just letting it sit out in the sun and hoping for the best.
Nope. It's about creating the ideal conditions. We might use water, covering the concrete with wet burlap, or even spraying it continuously. Sometimes we even use steam for a faster cure. It's fascinating stuff, really.
It sounds like it. But let's face it, even with the best engineers, the best materials, and the best processes, things don't always go according to plan, do they?
Unfortunately, you're right. Construction is full of unexpected challenges, and concrete, even with all its strength, is no exception.
So let's talk about some of those concrete conundrums. What are some of the common things that can go wrong, even when everyone's trying their best?
Well, we already touched on segregation, which is a big one. But another problem is bleeding.
Bleeding. Now that sounds scary.
It's not as gruesome as it sounds. Bleeding is basically when excess water rises to the surface of the concrete while it's setting.
Okay, so not blood, but still probably not a good sign.
Exactly. A little bleeding is normal, but too much can weaken the surface, making it prone to cracking and dusting. It's like the concrete equivalent of having a bad hair day, not a good look.
And probably not good for its long-term health either.
Exactly. And then there are air voids, which are essentially air bubbles trapped within the concrete. They weaken the structure, kind of like how a honeycomb is strong despite all those holes.
So how do you avoid those?
Proper compaction is key, like using vibrators to remove excess air during pouring. It's all about getting the right consistency.
Right. So it seems like preventing a lot of these problems comes down to meticulous attention to detail every step of the way. But even then, mistakes happen. So
Yeah.
how do you trace back what went wrong? Is it like a concrete detective show?
Huh. In a way, it can be. That's where the importance of record keeping comes in. From the moment we get our hands on the raw materials, everything is documented. The origin of the cement, the type of aggregates used, the mixed proportions, test results, all of it carefully recorded.
So it's like a birth certificate, a permanent record for that batch of concrete.
Exactly. And just as important as a medical history, because if a crack appears years down the line, we can go back and investigate. Was it a bad batch of cement? Did something go wrong during curing? These records help us figure it out.
That's amazing. So this documentation isn't just about bureaucracy. It's about accountability and learning from any mistakes that are made.
Precisely. It's all interconnected. From choosing the right materials to understanding the science behind the mix to careful execution and meticulous documentation, each step is critical in ensuring the quality and longevity of the concrete structures we rely on every single day.
It really is a hidden world. The next time I walk past a concrete building or bridge, I'm going to see it in a whole new light.
Me too. It really is amazing what we can achieve with a little bit of ingenuity and a whole lot of carefully controlled concrete.
It makes you appreciate the seemingly mundane things that make our modern world possible.
Absolutely. There's so much that goes unnoticed, taken for granted.
Well, we're hoping to change that one deep dive at a time. For our listeners, if you've learned something new today, if you've gained a new appreciation for concrete, we'd love to hear from you. And if you have any burning questions about concrete quality control or any other engineering marvels that pique your curiosity, don't hesitate to reach out. Until next time, keep your eyes open, keep asking questions, and remember, there's always more to discover, even the most
All right, everybody, welcome back. Ready to dive into a new topic.
Absolutely. Always ready to geek out about some engineering.
Today, we're talking all about concrete, specifically advanced concrete mix design, which sounds kind of like a mouthful. I mean, I know concrete when I see it, but
Yeah, most people don't realize how much goes into that gray stuff we see everywhere.
right, exactly. And we've got some really cool sources for this deep dive. We're looking at excerpts from a textbook on concrete technology, and we've also got an article on sustainable building practices.
Sounds like a great mix of information to really dig into what's happening in the concrete world. And it's a pretty important topic, too. I mean, concrete is everywhere, from sidewalks to skyscrapers.
Absolutely. So to kick things off, what exactly is advanced concrete mix design? Is it really that different from, just mixing cement and water and hoping for the best?
Well, I mean, at its core, concrete is still pretty much cement, water, and aggregates. But it's the advanced part that makes it really interesting. Think of it like this. Anyone can throw some ingredients together, but a master baker knows the exact proportions to get that perfect rise in texture. It's the same with concrete advanced mix design. It's about achieving that perfect balance of properties.
Okay, I'm starting to see where this is going. So it's more than just add water until it looks right. We're talking about a real science here.
Precisely. We're talking about manipulating the proportions of those basic ingredients and even adding in some extra special ingredients to achieve a specific performance goal.
Okay, now you've got me really curious. When we talk about achieving a performance goal, what are we talking about? What are those goals?
It's all about strength, workability, durability, A&E, of course, cost. And these goals, they change depending on what you're building. A skyscraper needs a different type of concrete than a sidewalk, right?
Right, that makes sense. You don't need a super strong sidewalk.
Exactly. So when we're talking advanced concrete mix design, we're talking about figuring out exactly how much of each ingredient to use, the right types of those ingredients to hit that perfect balance for what we're building. It's pretty cool once you start digging into it.
It really is. So let's talk about these ingredients. We've got cement, water, aggregates. Anything else I'm missing?
Those are the big three for sure. But like I was saying before, we can get a little fancy and add things called supplementary cementitious materials, or SCMs. Fly ash, slag, silica fume, these are all examples of SCMs.
SCMs, got it. But I have to ask, what exactly are those things? Like, what is fly ash and how does it magically make my concrete better?
Good question. See, fly ash is actually a byproduct of coal combustion, and slag comes from steel production. Basically, they're materials that might have just ended up in a landfill.
So we're talking about recycling here, turning something that might have been waste into a key ingredient.
You got it. And these SCMs, they do some amazing things. Fly ash, for example, can actually react with the cement and make the concrete stronger in the long run. It can also improve workability, making the concrete smoother and easier to place.
Wow, so not only is it good for the environment, but it actually makes the concrete better. That's a win-win in my book.
You said it. Now, slag, on the other hand, that's known for its durability. It helps concrete resist things like sulfate attacks, which can be a big problem in certain environments, and silica fume. Now, that's the powerhouse. It makes the concrete incredibly dense and strong. We're talking about using it for some seriously heavy-duty projects.
It sounds like we could do a whole other episode just on SCMs, but let's talk about the aggregates for a second. You mentioned earlier that there are different types.
Yeah, absolutely. Aggregates actually make up the bulk of a concrete mix, like 60 to 75% of the total volume. So getting those right is crucial. We've got fine aggregates like sand and coarse aggregates like gravel or crushed stone.
And I'm guessing, just like with the SCMs, the specific type of aggregate impacts the concrete's properties.
Exactly. The size, shape, and even the texture of the aggregates can affect the concrete's strength, workability, and durability.
This is so much more complex than I ever imagined. It's like a giant puzzle figuring out the perfect combination of all these different elements.
You got it. And speaking of complex, remember that self-consolidating concrete mentioned earlier?
Oh yeah, the concrete that basically pours itself. It sounded like something straight out of a sci-fi movie.
Right. It's pretty wild. Self-consolidating concrete, or SCC, is designed to flow under its own weight, completely filling the formwork and encapsulating all the reinforcement without the need for vibration.
Hold on, so no more of those noisy, vibrating things they use at construction sites. That's gotta be good for the environment and noise pollution too.
Exactly. It's quieter, faster, and generally safer because you don't have workers out there with those heavy vibrators. Plus, you can get really creative with the shapes you can create.
Okay, so how does it work? Is it like magic?
Well, it's not magic exactly, but it's pretty close. SCC uses a high percentage of fine materials and special admixtures, which are like chemical additives that reduce the friction between the concrete particles.
So it basically flows like a super smooth liquid.
You got it. And because it fills every nook and cranny on its own, you get a much denser, stronger, and more durable concrete.
It's amazing how far concrete technology has come. And speaking of advancements, we have to talk about sustainability. It's a huge topic these days, and rightfully so. How's the concrete industry doing its part to lessen its environmental impact?
That's a great question, and it's something the industry is taking very seriously. As we touched on earlier, using SCMs like fly ash and slag is a big part of it. It reduces the need for traditional cement, which is a major contributor to carbon dioxide emissions.
Right, because if I remember correctly, those SCMs are often made from byproducts that would otherwise end up as waste, right?
Exactly. But it goes beyond just SCMs. We're also looking at things like optimizing mix designs to use less cement overall. And there are even some really innovative ideas in the works, like developing concrete that can actually absorb carbon dioxide from the atmosphere.
Wait, really? So the concrete could actually help clean the air? That's amazing.
It's still in the early stages, but it has the potential to be a game changer in terms of sustainable construction.
It's exciting to think about. So with all these advancements in concrete, where are we seeing them used the most?
Honestly, it's everywhere. High-performance concrete is used in everything from bridges and tunnels to skyscrapers and dams. And SCC, well, that's revolutionizing the way we build complex structures and precast elements.
So the next time I'm stuck in traffic on a bridge, I can at least be thankful that it's probably made with some super strong, high-tech concrete.
Exactly. And those skyscrapers you see in cities around the world, they wouldn't be possible without the innovations in concrete design.
It's pretty amazing when you think about it. This humble material that we often take for granted is actually playing a crucial role in shaping our world.
It really is.
Well, on that note, I think we've definitely mixed up a whole lot of information on advanced concrete mix design today.
Definitely. We've barely scratched the surface, really.
That's true, but hey, that's the beauty of it, right? There's always more to learn and discover. So, listeners, next time you walk past a concrete structure, take a moment to appreciate the science, the engineering, and the sustainability that went into creating it. You might be surprised. All right, buckle up. We're going deep on something you probably see every single day. Yeah, without a second thought. Concrete. We've got a fascinating YouTube video from Civilians,
Okay.
a channel run by a civil engineer who really knows their stuff. We're going to break down the surprisingly complex world of concrete manufacturing.
You know what's really interesting to me?
What's that?
It's fascinating how often we overlook the complexity hidden right in front of us,
Yeah,
in plain sight.
totally.
Today, we're peeling back the layers on concrete, a material that's not just about sidewalks and buildings, but about chemistry, engineering, and even, dare I say, a touch of artistry.
And this video, it doesn't mess around. It jumps right in, defining concrete as a mix of cement, fine aggregate, coarse aggregate, and water.
Right.
Simple enough, right?
Yeah.
But what's the science behind the specific recipe?
Well, I mean, think about it this way. You wouldn't use the same concrete mix for a sidewalk as you would for, say, a massive dam.
Right.
I mean, the forces that they need to withstand are completely different.
Oh, yeah, for sure.
And that's where the why of this mix gets interesting.
Okay.
Cement acts as the binder, like glue holding everything together.
Okay.
Then you've got your aggregates, which are those rock particles.
Right.
These provide bulk and strength, much like flour does in baking.
Okay. Okay.
And finally, water.
Yeah.
This is key because it triggers a chemical reaction, allowing the cement to do its job and bind everything into that solid mass we know as concrete.
So there's actually a chemical reaction happening like right there under our feet.
Yeah, pretty much.
Mind blown.
Yeah.
And speaking of the aggregates, the video goes into some detail about, different types. And
Now-
honestly, I had no idea there was so much variety.
It's easy to think of aggregates as just rocks,
Right.
but the world of aggregates is surprisingly diverse.
Yeah.
You've got everything from like fine sand-like particles to like chunky gravel,
Oh, wow.
and each type plays a crucial role. For example, crushed stone, a common coarse aggregate, adds significant strength to the concrete, making it ideal for, high traffic areas or structures that need to bear like heavy loads.
Yeah. Yeah, totally.
On the other hand, using recycled concrete as aggregate is becoming increasingly popular, which is great for,
Sustainability.
sustainability.
Yeah, exactly. Yeah, I love that. It's like choosing the right flour for your cake, right?
Right.
You wouldn't use like cake flour for a crusty loaf of bread.
Exactly, yeah.
And speaking of like specific ingredients, did you notice the video used the phrase "passionnare"?
Oh, yeah.
My Hindi's a bit rusty, but it definitely caught my eye.
Yeah, that's a great catch.
Yeah.
It's most likely referring to Portland cement,
Okay.
the most common type used worldwide.
Gotcha.
It's a small detail, but it highlights how universal concrete manufacturing is.
Yeah.
From a small construction project in India to a towering skyscraper in Dubai, the same fundamental principles are at play.
So cool. Okay, so we've got our ingredients all laid out.
Okay.
What I love about this video is that it takes us on a step-by-step journey through the actual manufacturing process.
Right.
And it turns out there are 6 key stages: batching, mixing, transporting, placing, compacting, and curing.
Wow. 6.
Yeah.
And each stage is critical to ensuring the final product meets those, incredibly specific requirements we're talking about.
Right.
It's like a carefully choreographed dance with no room for error.
Oh, wow.
Take batching, for instance.
Okay.
It's all about precision, ensuring the right proportions of each ingredient are added to the mix. Imagine a tiny error in batching, say a little too much water.
Oh, okay.
It might seem insignificant at the time, but it can have a ripple effect, leading to weaker concrete that's prone to cracking.
It's amazing to think that something as seemingly simple as mixing concrete requires that level of precision.
Right.
But it makes sense when you consider the incredible loads and stresses these structures need to withstand for decades.
Exactly.
Mm-hmm.
And this precision continues into the mixing stage,
Yeah.
where those carefully batched ingredients transform into that familiar concrete slurry.
Right.
The video does a great job of showing both manual and machine mixing,
Yeah.
highlighting the contrast in scale.
That was pretty cool to see.
Yeah,
On one hand, you have, a small team mixing concrete by hand,
right.
which still happens in many parts of the world. And then you see these massive automated plants churning out incredible volumes of concrete.
Oh, yeah.
It makes you appreciate the ingenuity that goes into scaling up this process while maintaining that critical consistency.
And speaking of scaling up, the video then takes us to the next hurdle.
Yeah.
Transporting that concrete before it sets.
Oh, yeah.
It's a race against time, and it's fascinating to see those giant concrete mixer trucks in action.
Those things are like the workhorses of the construction world, right?
Oh,
You always see them on the highway, seemingly in a constant rush. Now I understand why. They're on a mission to deliver that concrete before it hardens.
absolutely.
So once they arrive at the construction site, what happens next?
It's time for placing. Pouring that concrete into molds or forms,
Okay.
which act as blueprints for the final structure, whether it's a simple sidewalk or a complex building foundation. The video highlights that this step requires, a keen eye and careful technique to ensure the concrete is evenly distributed and fills every, nook and cranny.
It's like pouring the batter for a cake, right?
Mm.
You want it to spread evenly and reach every corner of the pan. But I'm guessing there's a bit more at stake with concrete than a slightly lopsided cake, right?
Absolutely. We're talking about the structural integrity of buildings and bridges here.
Right, right. High stakes.
Exactly. And that's where the next stage, compacting, comes into play. It's all about removing air bubbles trapped within the poured concrete, because even tiny pockets of air can weaken the structure over time.
Mm.
The video mentions different methods, from handheld vibrators to larger machines,
Mm.
all with the goal of achieving the densest, strongest concrete possible.
It's amazing to think about all the invisible forces at play within, that seemingly solid slab of concrete.
Yeah.
It's a bit like those time-lapse videos you see of concrete drying. You don't realize how much is happening beneath the surface. But this is just the start of the concrete's journey, right?
Right.
I'm particularly intrigued by this whole curing process. It's not just about letting the concrete dry, is it?
Not at all. Curing is where things get really interesting.
Okay.
And it's often a misunderstood stage in the process. It's about controlled moisture loss as the concrete hardens. Think of it like this. Imagine baking a loaf of bread.
Okay.
If you don't let it cool properly, it can become dry and crumbly.
Right.
The same principle applies to concrete.
Interesting.
If it dries too quickly, it won't reach its full strength potential.
So it's more about managing the drying process than just waiting for the concrete to harden.
Exactly, yeah.
Huh. This completely changes my perspective on those wet concrete science.
Right.
Tell me more about these curing methods. The video mentioned a few that sound surprisingly intricate.
Yeah. It's not just about throwing a tarp over it and calling it a day.
Okay.
You have the basics like spraying or covering the concrete with water to, slow down evaporation.
Yeah.
But then there's also ponding,
Okay.
which involves creating a shallow pool of water directly on the concrete surface.
Wow.
And if you want to get really fancy, there's membrane curing, which uses specialized materials to control the rate of evaporation.
Oh, wow.
Each method has its pros and cons depending on factors like, the environment, the type of concrete, and the desired strength.
It's like concrete gets a spa treatment.
It really does.
All this attention to detail just goes to show how crucial this stage is.
Absolutely. This step is crucial for ensuring that the concrete lasts for years, if not decades.
Wow.
And believe it or not, curing doesn't mark the end of the concrete's journey. There's one final stage to discuss, the one that adds that final touch of finesse, finishing.
Ooh.
But we'll save that for after a quick break.
Finishing.
Yeah.
It sounds so glamorous.
Right.
Like the final brush strike on a masterpiece.
Yeah.
But we're talking about concrete here.
Yeah.
What's so special about this last step?
Well, think about the concrete structures you see every day.
Okay.
Some sidewalks are smooth as silk.
Right.
Others have, textured surface.
Yeah.
Some driveways even mimic the look of cobblestone.
Oh, yeah.
Finishing is what gives concrete its final, look and feel,
Okay.
impacting both its aesthetics and functionality.
So it's not just about making it look pretty.
Not at all. Well, aesthetics are important,
Yeah.
especially in, architectural applications.
Right.
Finishing also affects the concrete's durability,
Hmm.
slip resistance, and even its ability to like drain water.
So, like how some sidewalks have those grooves,
Yeah, yeah,
that help with traction when it's raining.
exactly. That's a result of a specific finishing technique.
Oh, okay.
And remember when we talked about the importance of uh, controlling moisture loss during curing?
Yeah, yeah. To ensure the concrete reaches its full strength potential.
Precisely. Well, finishing also plays a role in that.
Okay.
Certain finishing techniques can help, like seal the surface,
Mm.
further controlling evaporation and contributing to the concrete's, overall strength and longevity.
It's amazing how each step in this process,
Right.
even the seemingly like minor ones,
Yeah.
has these ripple effects on the final product.
It's a testament to the intricate science and engineering behind this material that we often take for granted.
I know. This deep dive has been a real eye-opener.
Yeah.
But before we get like too philosophical about concrete,
All right.
I'm curious to hear more about these finishing techniques.
Yeah.
What are some of the most common ones?
Well, the video touches on a few.
Okay.
For a smooth finish, think troweling.
Okay.
It's like smoothing out icing on a cake.
Right.
But instead of a spatula, you use a tool called a trowel.
Gotcha.
This is what gives you that classic sleek look you often see on like floors or countertops.
Okay.
Then there's brushing,
Yeah.
which creates those subtle grooves that enhance traction.
Okay.
And for, more decorative applications,
Yeah.
you have stamping,
Okay.
where patterns or textures are imprinted onto the surface, like those cobblestone driveways you mentioned.
So it really is like concrete artistry.
Yeah.
And I bet each of these techniques requires, specific tools and expertise.
You bet.
Wow.
And just like with the other stages of concrete manufacturing, timing is crucial in finishing.
Yeah.
The concrete needs to be at just the right stage of hardening, not too wet, not too dry, to achieve the desired results.
It sounds like this final step requires a delicate balance of skill, timing,
Yeah.
and a little bit of artistry.
It's true.
It's amazing to think about all the factors that go into creating something that seems
Right.
so simple at first glance.
It really is.
Yeah.
And it speaks to the ingenuity of the people who work with concrete every day.
Yeah.
From the engineers who design these complex mixtures to the, skilled laborers who bring those designs to life.
Right.
It's a true collaboration of science, craftsmanship,
Wow.
and a deep understanding
Yeah.
of this versatile material.
It's like we've uncovered this hidden world of concrete, the chemistry, the engineering, the artistry. So what does it all mean?
Yeah.
We've gone through this entire journey,
Right.
from the basic ingredients to the final finishing touches.
Right.
What's the takeaway for our listeners?
It's easy to walk through our daily lives without giving a second thought to the concrete that literally forms the foundation of our world.
Right.
But by understanding, the complexity, the precision, and even the artistry that goes into making this material, we gain a whole new appreciation for the built environment around us.
Next time I'm walking down the street,
Yeah.
I'll be looking at sidewalks, buildings, even bridges with a whole new perspective.
I love that.
I might even catch myself admiring the smoothness of a concrete countertop.
Right.
And if you really want to impress your friends, you can casually mention the importance of proper curing techniques
Yes.
or the subtle art of concrete finishing.
Exactly. Become a concrete connoisseur.
I'll be sure to drop some concrete knowledge at my next dinner party.
Please do.
But seriously, this deep dive has really highlighted how something we often overlook can be surprisingly complex
Yeah,
and even beautiful in its own way.
that's true.
It's funny how something, so ubiquitous, so
Yeah.
seemingly mundane can
Right.
hold so much hidden depth.
It's a testament to the power of curiosity, isn't it?
Hmm.
We often take for granted the materials and processes that, shape our world.
Yeah.
But with a little digging,
Yeah.
we can uncover fascinating stories of ingenuity, science,
Right.
and even art.
And concrete is a perfect example. This deep dive has completely changed the way I see those sidewalks, those
Yeah.
buildings, those bridges. It's like we've been let in on a secret, a hidden language of construction.
And now you can start to decipher that language.
Right.
You'll notice the different types of aggregates used in different applications,
Oh, yeah.
the subtle textures created by different finishing techniques,
Right.
even the telltale signs of proper curing.
I'm already finding myself looking at concrete structures with a more discerning eye.
That's great.
And you know what else I find fascinating?
What's that?
This idea that even something as seemingly permanent as concrete is constantly evolving.
Absolutely.
Wow.
We touched on the use of recycled aggregates,
Yeah.
which is a great example of how sustainability is becoming, increasingly important in the world of concrete.
Sure, sure.
And there are some incredible innovations happening with concrete technology,
Okay.
like self-healing concrete
Oh, wow.
that can repair cracks on its own,
What?
or concrete that can, like, purify the air around it.
Okay, now that's just straight out of a science fiction novel.
Mhm.
Self-healing concrete. That sounds almost too good to be true.
But it's a testament to the incredible creativity and problem solving happening in this field.
Wow.
As we face new challenges from, climate change to urbanization, concrete is being called upon to do more than ever before.
Right.
And from what we've learned today, it seems like concrete's up to the challenge.
It really does.
So the next time you're walking down the street, take a moment to appreciate the silent symphony of concrete around you.
Yeah.
It's a symphony of chemistry,
Right.
engineering, artistry,
Yeah.
and even a touch of magic.
I love it.
And who knows, you might even find yourself inspired to learn more about the hidden depths of, other everyday wonders around you.
Mm,
After all, that's what the deep dive is all about.
that's what it's all about. I love it. Well, thanks for joining me on this concrete adventure. It's been a really fun one.
My pleasure.
And to all of our listeners out there, keep exploring, keep asking questions, and most importantly, never stop digging for those hidden depths because you never know what
Ever find yourself wondering why some concrete structures seem to last forever, while others crumble before our eyes?
Yeah, it really makes you wonder what's going on behind the scenes, doesn't it?
Like, how do they make concrete for those massive dams or bridges that stand for centuries?
Right. It's not magic, though it sometimes seems that way.
Well, get ready to demystify it, because today we're doing a deep dive into the fascinating world of durable concrete.
Ah,
We'll uncover the secrets of its longevity.
we're talking about the science, the engineering, and even a bit of art that goes into making concrete that can withstand the test of time.
Okay, so let's start with the basics.
Mhm.
When we talk about durability in concrete, what are we actually talking about?
Well, in simple terms, you can think about it as concrete's ability to be tough, to resist all those things that try to break it down.
Like what specifically? Give us the concrete enemies.
Well, you've got the usual suspects,
Hmm.
harsh weather conditions, those freeze-thaw cycles.
Oh, yeah, makes sense.
And then you have to worry about chemical attacks, things like sulfates or chlorides that can really do a number on concrete.
And of course, just the wear and tear of everyday use.
Right.
I mean, think about all the traffic on a busy highway, for instance.
Exactly. So durability is really about how well the concrete can stand up to all those challenges while still doing its job.
Okay, so I'm already starting to see how this is way more complex than just mixing some stuff together and hoping for the best.
Oh, absolutely. It's a whole science. You have to think about the materials you use, the way they're mixed, the environment the concrete will be exposed to.
Right, because a concrete structure in the middle of the desert is going to face very different challenges than one built on a windy coastline.
Precisely. So let's break down some of the key factors that influence concrete durability, shall we?
Let's do it.
First and foremost, it all starts with the ingredients. Just like baking a cake, you need the right stuff in the right amounts.
So what are we working with here? Cement, obviously, but what else goes into the mix?
Right, cement is crucial, but you also have aggregates, which are basically sand, gravel, crushed stone, things like that. They give the concrete its bulk and strength.
Okay, and what about the water? I mean, it can't all be dry ingredients, can it?
Water is essential. It's what activates the cement and starts the whole hardening process. But even the quality of the water can impact the concrete's durability.
Wow, I had no idea there were so many things to consider. And I'm guessing there's even more to it than just the basic ingredients.
You bet. Remember those admixtures we talked about earlier?
Oh, right, those secret ingredients you mentioned. What
Okay.
exactly do they do?
Well, think of them as boosters, like adding protein powder to a smoothie. They're ingredients added in small amounts that can drastically enhance the concrete's properties.
So you can tweak the recipe to make the concrete more resistant to specific threats, depending on where it's going to be used. That's pretty cool.
Exactly. For example, in areas prone to freezing temperatures, you might use an air entraining admixture.
Air and training, huh? What does that do?
It creates tiny air bubbles within the concrete, which gives the water space to expand when it freezes, preventing those damaging cracks.
Ah, it's like giving the concrete a little bit of breathing room.
Exactly. And then there are other admixtures that can improve workability, increase strength, or even speed up or slow down the curing time, depending on the project needs.
So it's a bit like having a toolbox full of specialized tools. You choose the right admixture depending on the specific challenge you're trying to overcome.
That's a great analogy. And it's this level of customization that makes concrete such a versatile and durable building material.
So we've talked about the materials, but what about the way they're combined? Is there a right way and a wrong way to mix concrete?
Oh, absolutely. That's where the mixed design comes into play. It's like a recipe that dictates the exact proportions of each ingredient.
So it's not just throwing it all on a giant mixer and hoping for the best.
Not at all. Getting those proportions right is crucial, especially when it comes to the ratio of water to cement.
Why is that ratio so important?
Think of it this way. Too much water might make the concrete easier to work with initially, but it can weaken the final product and make it more porous.
Porous, meaning more holes and spaces for water to seep in.
Exactly. And that's a recipe for disaster when it comes to durability. Water expands when it freezes, putting pressure on the concrete from the inside out.
Right, like that bursting ice cube tray we talked about. So too much water is bad, but what about too little? Doesn't that make it difficult to mix properly?
Exactly. Too little water, and the cement might not fully hydrate, leading to a weaker, less durable concrete.
So it's all about finding that Goldilocks zone, just the right amount of water for a strong and durable final product.
Precisely. And of course, the mixing process itself is important too. It needs to be thorough to ensure all the ingredients are evenly distributed.
It's amazing how many factors are involved even before the concrete is poured and shaped.
I know, right? And speaking of pouring, once the concrete is placed, the next critical step is curing.
Curing, what does that mean?
It's basically like letting the concrete rest and gain strength. It's a carefully controlled process that allows the cement to fully hydrate and the concrete to reach its maximum strength and durability.
So it's not just a matter of letting it sit there and dry out.
No, it's a bit more involved than that. Proper curing involves maintaining moisture and temperature levels to ensure the chemical reactions within the concrete happen at the right pace.
And how long does this curing process usually take?
It varies depending on the type of concrete and the environmental conditions, but typically it takes several days or even weeks for the concrete to reach its full strength.
Okay, so we've got the materials, the mixing, the curing, but even with all that, concrete still doesn't get to just live a peaceful life, does it?
Yeah.
It's constantly being bombarded by the elements.
You're absolutely right. The environment throws a lot of curveballs at concrete, so understanding those challenges is key to ensuring its long-term performance.
So let's talk about some of those concrete enemies, shall we?
Sure. Let's start with those freeze-thaw cycles we mentioned earlier. That one's a biggie, especially in colder climates.
Right, because when water freezes, it expands. And if that's happening inside the concrete, it can cause it to crack and deteriorate over time.
Exactly. Think of it like filling an ice cube tray too full. The water expands when it freezes and can cause the tray to crack.
So how do you protect concrete from this constant freeze-thaw cycle?
Well, remember those air and training admixtures we talked about? They're a key defense mechanism. By creating tiny air pockets within the concrete, they provide space for that expanding ice to go without putting too much pressure on the surrounding concrete.
It's like giving the ice a place to escape to. Makes sense.
Right. Now, another challenge concrete faces is chemical attack, which can be a bit sneakier, but just as destructive.
We touched on this earlier, but can you give us some specific examples of these chemical villains?
Sure, one of the most common culprits is sulfate attack.
Sulfate attack. Sounds serious.
It is. Sulfates are naturally occurring minerals found in some soils and groundwater. When they react with the concrete, they can cause it to expand and crack over time.
It's like the concrete is being eaten away from the inside out.
It's a good way to think about it. Another common chemical attack is chloride ingress, which is a big problem in coastal areas or anywhere de-icing salts are used.
Yeah, salty air or those salts on the road can actually damage the concrete.
Exactly. The chlorides can penetrate the concrete and corrode the steel reinforcement bars or rebar that are often used to give it added strength.
So it's not just the concrete itself that's vulnerable, but also the metal inside it.
Exactly. And when the rebar corrodes, it expands, putting pressure on the surrounding concrete and causing it to crack and spall.
Spall, what does that mean?
It means that pieces of the concrete actually break off, which can weaken the entire structure over time.
So we've got the freeze-thaw cycles, chemical attacks, and then there's this whole hidden thread of corrosion happening from the inside. That's a lot for concrete to deal with.
Right, and it's why understanding these durability challenges is so crucial for engineers. Because armed with that knowledge, they can design and build concrete structures that can truly stand the test of time.
So knowing all that, what are some of the ways that engineers can actually make concrete more durable?
It all starts with good design. That means carefully considering the environment the concrete will be exposed to, the loads it will carry, and the lifespan it needs to achieve.
So it's kind of like choosing the right tool for the job, but in this case, you're designing the tool itself.
Exactly.
Hmm.
And part of that design process involves selecting the right materials, including the right type of cement, aggregates, and admixtures. Remember, different materials have different properties and resistances to various threats.
Right, like choosing a tougher, more weather-resistant type of wood for outdoor furniture.
Exactly. And just like you might seal or stain that wood to protect it further, we also have ways to protect concrete surfaces.
Ah, so this is where those coatings and sealants come in, right? Tell us more about those.
Right. Think of them like a shield that protects the concrete from external threats.
Yeah.
Coatings and sealants create a barrier that can prevent water from seeping in, resist chemical attacks, and even protect against abrasion.
So it's like giving the concrete its own little suit of armor.
Exactly. And just like you might choose a different type of armor depending on the battle you're facing, there are various types of coatings and sealants designed for specific applications.
So if you're building a bridge in a coastal area, you might use a sealant that's specifically designed to resist saltwater corrosion, right?
Exactly. And in areas with heavy traffic, you might use a coating that's designed to resist wear and tear.
Fascinating. It's amazing how much thought and science goes into something that most people probably never even think twice about.
I know, right? But it's this attention to detail that makes all the difference in the long run when it comes to creating durable infrastructure.
And speaking of the long run, I imagine maintenance also plays a big role in ensuring that concrete structures last as long as possible.
You got it. Even with the best design and construction practices, regular maintenance is essential to catch and address any potential problems before they become major headaches.
So it's like anything else. Regular checkups are way better than waiting for a major breakdown.
Exactly. Regular inspections can help identify cracks, spalling, or signs of corrosion so that repairs can be made early on, preventing more extensive damage down the road.
And I'm guessing those repairs might involve some of the techniques we've already discussed, like using special coatings or sealants.
Exactly. Sometimes more involved repairs might be needed, such as patching cracks with specialized repair mortars or even replacing sections of damaged concrete.
It makes you appreciate those construction workers even more.
It really does. And studying real world structures, both the successes and the failures, provides invaluable lessons for engineers and architects.
It's like learning from the past to build a better future. So next time you're walking across a bridge or even just down the street, take a moment to appreciate the intricate dance of science, engineering, and environmental awareness that went into making that concrete last.
I'll second that. It really is a marvel of engineering when you stop to think about it.
It really is. Well, on that note, thanks for diving into the world of durable concrete. Okay, I'll admit, when I think concrete, I picture, well, sidewalks, buildings. Not exactly the most thrilling stuff.
Yeah, you don't exactly picture innovation, right?
Exactly.
Yeah.
But we're diving deep into concrete today, and let me tell you, after this research, boring is the last word I'd use.
It's mind-blowing, actually. The tech coming out, what this could mean for how we build cities could be radically different.
No kidding. We've got articles, sustainability reports, even some military documents about this stuff, ready to push the boundaries.
Let's do it.
So first off, when I see self-healing concrete, I think, okay, what is this? Sci-fi. But it's real.
And it's as wild as it sounds. Imagine bacteria, like the tiny stuff, are mixed right into the concrete itself.
Get out of here. So what, these little guys are like construction workers.
In a way, if a crack forms, and water gets in that activates them, they start producing this limestone-like material.
Hold on. So they basically heal the crack from the inside out.
Pretty much. And this isn't some temporary fix. This is legit extending the lifespan of, say, a bridge by potentially centuries.
Centuries. Okay, the cost savings alone on repairs, that's got to be huge.
Massive. And the environmental impact. Way less waste, way fewer materials needed long term. Sustainability goldmine.
Which is a perfect segue because then there's recycled concrete, right? We're not just stuck making new stuff endlessly.
Right. Demolishing a building. Instead of landfill-bound rubble, we're talking about grinding that concrete up, processing it.
So it's not just like chucking chunks of old sidewalk into a new mix, right? There's got to be more to it.
Oh, absolutely. It's got to meet specific standards, different processing techniques. But the core idea is reusing what we've got.
Makes you wonder why we weren't doing this all along. I mean, talk about a no-brainer for sustainability.
It's gaining traction, especially as we realize how crucial all this is for the environment.
And then there's the smart aspect. Sensors embedded right into the concrete. It's like giving buildings a nervous system.
That's a great way to put it. Think about it. These sensors are constantly monitoring for tiny changes, things we'd never catch.
So stress from weight, temperature swings, even stuff like rust or cracks, forming way before they become a problem.
All of that. And that data, it's transmitted instantly. Engineers get real-time updates on the structure's health.
Meaning a bridge could basically tell us it needs attention before anything major goes wrong.
Precisely. Talk about a game changer for safety, for maintenance. The possibilities are huge.
Huge is an understatement. And we haven't even gotten to the stuff that sounds straight up impossible, like air purifying concrete.
You think I'm kidding, right? But nope, this is real. One of the biggest culprits of greenhouse gases, concrete production.
Yeah, I've heard that. All those chemical reactions, right? So how do you even begin to make that process eco-friendly?
Well, they figured out ways to actually capture carbon dioxide, the stuff we're trying to reduce and use it.
Wait, in the concrete itself, how does that even work?
It's called mineralization. As the concrete hardens, the CO2 gets chemically bound within it, locked away basically.
So it's not releasing that CO2 back out. That's incredible. Two birds, one stone, reducing emissions and making the concrete itself
stronger. Yep. It's a win-win situation, really pushing the boundaries of what concrete can do.
Speaking of pushing boundaries, we got to talk about 3D printing with concrete. This isn't some futuristic dream anymore.
It's incredible, isn't it? We're talking massive printers constructing entire houses layer by layer.
It's wild and faster, more efficient, right? Less material waste.
Exactly. And the designs they're able to achieve are mind-blowing. Complex shapes, intricate details, all made possible by 3D printing.
It's like something out of the Jetsons, but it's happening now.
Okay.
But with all these fancy features, how's the strength hold up?
That's where ultra-high performance concrete comes in. We're talking 4 or 5 times stronger than your average concrete.
Okay, now that sounds like what I imagine concrete should be. So what's it used for? Super bunkers, skyscrapers.
You got bridges that can withstand earthquakes, skyscrapers built to last centuries. If you need durability, UHPC is it.
And then, just when I thought it couldn't get any cooler, light transmitting concrete. That's not just a fancy name, is it?
Nope. Imagine this. Sidewalks that glow, buildings that shimmer with light, all thanks to optical fibers embedded in the concrete.
I saw pictures, and it's beautiful. But is it just aesthetics, or is there a practical side to it?
It's both. Sure, it's visually stunning, but think about the applications. Lighting up walkways for safety, creating unique art installations.
So from cleaning the air to glowing in the dark, concrete's not just about sidewalks anymore, is it?
Not even close. It's a material being constantly reinvented, and it's exciting to think where it'll go next.
Makes you look at every building, every bridge a little differently, doesn't it?
It really does. This seemingly simple material. It might just hold the key to a more sustainable and even more beautiful. All right, future builders and concrete connoisseurs, are you ready?
Ready for what? What are we talking about?
We're diving headfirst into the fascinating world of concrete. This is Module 9, but trust me, we're going way beyond the textbook here.
Sounds intense. So, no more equations and formulas.
Well, maybe a few, but this is about understanding how those formulas translate into those jaw-dropping structures we see every day. We're talking bridges spanning across vast rivers, roads connecting entire countries.
And let's not forget those skyscrapers almost touching the clouds. When you really think about it, it's amazing. Concrete starts as this, well, almost like a basic paste, but then it ends up shaping our entire world.
Exactly. It's the foundation of so much, and this module really digs deep into that. Remember all those real-world examples we talked about?
Oh yeah, the bridges, the roads, the buildings, even those massive dams. Don't forget the marine structures too.
Oh, right. The stuff you don't even think about, like those giant concrete pillars holding up piers. It's mind-blowing how one material can be so versatile.
Right. And that's where understanding the science behind it becomes super important. Like, take dams, for example.
Okay, so we're talking about structures holding back millions, no billions of gallons of water. How does concrete not just crumble under that pressure?
It's all about choosing the right type of concrete and then engineering it to withstand that specific type of force. Dams often use something called roller compacted concrete, which is, well, as the name suggests, incredibly dense.
Makes sense. It's got to be tough to resist all that water pressure
Exactly. And it's a whole different story when you're building a skyscraper.
because then you're battling wind loads and gravity, right?
Exactly. So the concrete mix you'd use for a skyscraper needs to be strong, but also flexible enough to handle swaying in the wind.
Wow, so there's a lot more to concrete than just mixing some stuff together and pouring it, huh?
Way more. Remember that whole section in the module about mixed design? That's where things get really interesting. It's like a delicate dance between art and science.
Okay, now you've got me really intrigued. Break it down for me. What's involved in this concrete mix design?
Well, it starts with knowing what you're building and where. Then you choose your ingredients carefully. We're talking specific types of cement, different sizes of aggregates, that's the sand and gravel, and
And then, don't leave me hanging.
a secret sauce, add mixtures. These are chemicals that can give the concrete superpowers.
Superpowers, like what? Can we make concrete fly now?
Not quite flying, though, that would be cool. But we can make it cure faster, make it resistant to freezing, even change its color.
Whoa, that's amazing. So it's like customizing the concrete for each specific project.
Exactly. And one of the most crucial aspects is the water-cement ratio. Get that wrong, and your whole structure could be compromised.
So what happens if you, say, use too much water?
Too much water weakens the concrete, too little, and it won't mix properly. It's like finding the perfect balance, and that's where all that manufacturing and testing come into play.
Yeah, the module really stressed the whole precision thing. They weren't kidding when they said it's like a science experiment.
Right. Except instead of a baking soda volcano, we're talking about structures people will live, work, and drive on. The stakes are a bit higher.
That's a lot of pressure. Speaking of pressure, what about those super tall skyscrapers? Those must be a whole other level of engineering.
Absolutely. That's where case studies become really valuable. By examining these amazing feats of engineering, we can learn so much. Take the Burj Khalifa, for instance.
Oh, wow, the Burj Khalifa. That's like the poster child for pushing the limits of what's possible.
Exactly. They had to develop a special high-performance concrete just to withstand the stresses of being that tall. And the pumping, getting the concrete up hundreds of meters, was a feat in itself.
That's incredible. It's amazing how engineers are constantly pushing the boundaries of what concrete can do. But, and I know the module touched on this, can we talk about sustainability?
Right, because it's not just about building bigger and taller, it's also about building smarter and greener.
Exactly. Concrete has a pretty big environmental footprint. What are we doing about that?
There's a ton of research going on right now. Some really promising avenues are using recycled aggregates, developing what's called geopolymer concrete, which has a lower carbon footprint.
Wow, geopolymer concrete, that sounds pretty high tech. What is that exactly?
It's a type of concrete that uses industrial byproducts like fly ash, reducing the need for traditional cement, which is a major contributor to those carbon emissions.
That's incredible. It's like we're turning waste into something that can build the future. So it's not just about making concrete greener, it's also about using fewer resources, right?
Exactly. Resource scarcity is a huge concern, and researchers are exploring alternative materials, optimizing mixed designs to use blend material. It's all about finding creative solutions.
It's almost like we're not just building structures, we're shaping the future of construction. But with all the challenges facing the world, like climate change, how can we make sure our concrete creations can stand the test of time and the elements?
That's the million-dollar question, isn't it? And it's one that you, the future engineers and builders, will need to grapple with. Think about it. If you were designing a bridge today, what would be your top priority? Would it be minimizing its carbon footprint, ensuring it can withstand harsher weather conditions,
Hmm?
or perhaps finding that sweet spot between being cost-effective and durable?
It's a lot to consider, but that's what makes this field so exciting. It's not just about the materials, it's about finding innovative and sustainable ways to build a better future. And from the sounds of it, the future of concrete is full of possibilities.
Sure is. It's a field ripe for innovation and change.
Well, on that note, I think it's time to wrap up this deep dive. We've gone from basic formulas to tackling global challenges, and honestly, I'm even more impressed by concrete than I was before.
Me too. And the best part, we're just scratching the surface.
So, to all our listeners out there, keep exploring, keep questioning, and keep building. Who knows what incredible concrete creations you'll bring to life? Until next time,